Yeah, so in this question for the, what was it asking you to do? You want to integrate, let me, hold on, pause a while. Let me find the question first. Okay, it was the supplementary. Oh, it's not this one, sorry. Uh, which one was it? Okay, I am confused. EJC tutorial. Okay. Right. Okay, Ken, sorry. Hello.
Hello.
Yes. So question 4, right? This is what we are starting with. X plus 2 divided by 1 minus square root 3x squared. So this guy, let me see what you did first. Oh, it's fine. For part A is fine. Part B, part C is fine. But part D got problem. Okay, for part D. Let's go. So over here, for part D, you got 1 over x times 4 plus ln x bracket square. So the thing here is the answer, they straight away give you half tangent inverse ln x over 2. I think that requires a bit more elaboration. So let me show you. What you did was like just not correct. Let me explain why yours is not correct first. So first one, you let fx equals to 4 plus ln x bracket square, right?
Yeah.
Then you differentiate it. So 4 differentiate gets 0. But here, ln x bracket square, it is not the same as 2 over 2 times 1 over x. Are you aware? Can you see that there's actually two functions here going on? There's actually a f of x equals to, I don't know, ln x. Then there's a g of x equals to x square. Then this ln x bracket square is actually referring to g of f of x. Does that make sense?
Yeah.
So when you got composite function, right? Chain function or something inside another function inside another function, what rule do you need to use? Chain rule. So the outside function is what? G, which is x squared. So how to differentiate x squared? Bring down the 2 in front, then minus 1 to get the new. 2 minus 1 is 1, so that's why you have ln x power 1. Then after that, the inside is ln x, you have to differentiate, you get 1 over x. So the actual answer is 2 ln x over x.
Oh.
So that's why totally wrong already. It's not 2 over x, then error carry forward. It doesn't work. And also here, it's not 2 ln x over x, so it doesn't work. Okay, then how? So yeah, so this doesn't work. Your actual derivative Okay, I think what you got mixed up with is the difference between ln x bracket square versus ln of x square. These two guys are very different. Can you see? Ln x bracket square means ln x times ln x. You have no identities for product of logarithms. We only got plus between a logarithm, minus between a logarithm, or logarithm with a power inside, which is this case here. Then you can bring down the power. Here, it is different. The power is outside of the ln. It is not inside of the x square. It's not attached to the x square. It's attached to the entire logarithm. So therefore, you cannot bring down the power. Okay, the 2 cannot bring down in front. Are we clear on that?
Yeah.
Okay, good. Then what else? Okay, yeah. So that's why your entire question is wrong for part D. Let me show you how to do it. Okay, so first thing you need to recall is this guy. Integral of 1 over 1 plus x squared dx equals to tangent inverse of x, right?
Yeah.
You differentiate the right side, you can get back to the integrand. Integrand is the guy in the middle here. Then how about if I change the x to ax plus b? Oh, I just need to get the same answer, tangent inverse of ax plus b, but replace the x with ax plus b. But because derivative of ax plus b is what? A, right? So you have to divide by a. Or in other words, if I times a on both sides of the equation, then I'll get a here and no more a here. It will cancel off. The a will cancel off. A times 1 over a. So you're left with this guy. Agree?
Yeah.
And more generally, do you realize that this a on top is really just a derivative of ax plus b? So that means that we can derive the general version of this formula, which is from this, not really derive, but more like we can see that the general formula for this would be f prime x on top instead of a divided by 1 plus f of x bracket square dx. The integral is tangent inverse of f of x. Is this part clear to you? It's just where fx equal ax plus b. Or more generally, it's just f of x. Can. So this is not available in the formula list. The trick here is there is always a 1 over here. Go back to the summary. Remember this summary?
Yeah.
Go back down. We are at the f part, and then we are at this stage over here, where you have a very funny a square, and then divide by a. I don't like a, I prefer 1. So I always substitute my a with 1. I integrate 1 over x squared plus 1, I get tangent inverse. If I replace the x with px plus q, then I just divide by p. If there's an a square, then no choice, I have to divide by a. But here, I forgot to mention to you that there is the more general form, which is that if you replace the x with px plus q, you can also more generally replace the x with fx. So I will update this. I will update this by drawing another branch. You replace the x with, this time you replace the x with f of x. In that case, the general formula must be f prime x on top divided by 1 plus bracket f of x bracket again square dx equals to tangent inverse of bracket. What's inside? Is it still x?
The fx.
Fx, exactly. Plus c. Okay, now that you know this formula, we can proceed to solve the question. So here, do you realize that 1 over x times something, you can actually bring the x on top, so you get 1 over x?
No.
But I mean, okay, but do you agree it's true?
Yeah.
Yes. Why do we want to do that? It's because you see the ln x over here, then bracket square. Doesn't it look like a fx bracket square?
Yeah.
Yes. But then the derivative of ln x is what? 1 over x. There we go. You have f prime on top. Then we got f below. But wait a minute. That's not correct. Why? Because here, what do you see?
The 4.
4. What do we want in our formula?
1.
So how do we get a 4 turned into 1? Very simple. It just, do you know how I went from here to here?
Yeah.
I divided by 4. Let me show you. So what I'm doing is I am multiplying the top by 1/4, the bottom by 1/4. Correct or not? If I multiply by 1/4 at the top and bottom, they'll just cancel each other off. So I'm just multiplying by 1. Multiplying by 1 doesn't do anything, so it still stays equal. But here is a very special format of 1, which is 1/4 over 1/4. Why? Because now I can take fraction times fraction, just numerator times numerator. So 1/4x. And then the denominator times denominator. So there's an invisible pair of brackets around it, then times 1/4. Distribute into the first term. 1/4 times 4, you get a 1. 1/4 times ln x square, you get ln x square over 4. Clear so far?
Yeah.
I use an analogy here with a 1/7 over 5 plus 9. Then here okay, wait, no, this one is just to explain the first step. But this second step, I didn't elaborate. But anyways, up to this step, is it okay? Yes,
Yeah, Kim.
Okay, good. Moving on. So now that we have ln x square over 4, we can rewrite it as ln x bracket square over 2 square, which is ln x over 2 bracket square. Then in that case, we can realize that since we have ln x over 2 as the function in between the bracket, no longer just ln x, we should let our fx equal to ln x over 2. Then I just rewrite it as half ln x to make it clearer. Then I differentiate half ln x. I'll just get half, but differentiate ln x, I get 1/x. Simplify as 1/2x. So that means that my numerator on top, this is my f of x. On top, I need f prime x, which is 1/2x. But how do I get from 1/4x into 1/2x? I just factor out a half. So far, so clear? This part? Can, then this half I just factor out just to make it look nice. So I get half multiplied by the integral of 1/2x over 1 plus ln x over 2 square dx. So this is really already in the format of 1 over f prime x. Then you divide by 1 plus bracket square. Inside is f of x, then dx. Where f of x is half ln x, f prime x is 1/2x. Clear?
Yeah.
Then therefore you can just use the formula now. It's tangent inverse of ln x over 2, but with an extra half in front. That's your answer. Okay?
Okay.
The trick here is to make the 1. Make the 1 here. Okay? And you see a plus, then you know it must involve tangent inverse. If you see a minus, then you know you need to do partial fraction or use the standard formula ln of something over something. I cannot remember for the life of me. I'm not gonna try and remember it. I'm just gonna do partial fractions. But plus that one, I remember it as tangent inverse. Oh, have I explained to you why it should be tangent inverse? Like the very first formula here. The proof. Have I shown you before?
No.
No. Okay. I give a quick one. Why should the integral of this one be tangent inverse? It's because you differentiate tangent inverse, you get to 1/1 plus x squared. Here's how we do it. So first we want to let y equals to tangent inverse of x. Our goal is to find out an expression for dy by dx, which is differentiating tangent inverse. What is it equal to? Here's how we do it. First, you see tangent inverse, you straight away bring back. So you get tangent of y equals to x. So when you see tangent of y equal to x, you can immediately rewrite as x over 1. Correct or not?
Yeah.
Then tangent y equal to x, you've done a lot of substitution integrals already. Integration with substitution. So you should know this angle here, it's not theta, but rather it's tangent of y. So the angle should be a y here. Then you know tangent is what? So what over what?
Opposite over adjacent.
Opposite over adjacent. So straight away you can see with respect to this right angled triangle with angle y, opposite would be here. So I put an x, adjacent would be there, I put a 1. Then how do you find hypotenuse?
The square root of x squared plus 1 squared.
Yes, correct. Okay, then therefore you take the square root, just take the positive root, we will assume that's the case. Then what's tangent of y? Well, yes, it is just x over 1 if you look at the diagram, but that's not useful. What we're going to do now is to introduce differentiation. We're going to differentiate both sides of the equation. So d by dx, d by dx. But then you have a problem here. It's a y and the x. It's different. So what do you need to use? What kind of differentiation?
Implicit differentiation.
Yes, correct. So you first differentiate tangent, you get secant square, but you keep the same letter. Then now you have the inner function y, you have to do chain rule. So you multiply by the derivative of the inside with respect to x. With respect to x, okay, then y. Of course, that's really just dy by dx. That's what we want already, right? We want to solve for dy by dx over there. So that means that this will be equal to differentiating right-hand side, differentiating x with respect to x. It's just a 1. Solve for dy by dx. What do you get? 1 over secant square of y. What's secant again? Secant means, say secant y, 1 over cosine y. So if you square it, you also square it there. Square both sides. So 1 over secant square is actually 1 over cosine square. So let's just figure out what's cosine square first. Or just cosine y. Look at the diagram. Cosine y is
1 over the square root of 1 squared plus x squared.
I simplify as 1. I never write the square anymore. Then after that, I take the cosine square. I think you can see already the square root will disappear. You're left with 1 square, which is 1, divided by square root square, cancel off. Just 1 plus x squared. Yes?
Yeah.
Then 1 over means you flip it around. So that means that, wait, actually, no. I should work with this 1 over secant square. It's really just cosine square. Correct or not? 1 over secant square. Just flip the fraction around, so it's cosine square. But we already found out cosine square, so it's really just 1 over 1 plus x squared. There we go. We got our formula. Y equal tangent inverse dy by dx is 1 over 1 plus x squared. Can? Then this is provided in the formula list. But this is how you derive it. Is that okay? Same as sine inverse and cosine inverse, provided in MF26. You just need to memorize it and know that you need to use it. Integrate, but integration, it goes in reverse, right? So dy by dx equals to this 1 over 1 plus x squared. Integrate, then you get back to y. Integrate, then you get back to tangent inverse. Okay? Clear?
Yeah.
Okay, moving on. So next one, 4D done already. 4E, what happened? Did I not mark it? Let me double check your 4E. 4E, x ln 2x plus 1. Let me see. Minus x plus half ln 2x plus 1 plus c. Oh no, what happened? Why is there missing half? Okay, your answer is mostly correct. It's just missing a factor of half. Let me show you. Yeah, so this guy over here, there's a problem. It should be half ln mod 2x plus 1. Okay, let me see your working. What happened now? Ln 2x plus 1, straight away you times 1, that's correct. Then you pick the u to be ln 2x plus 1 and dv by dx to be 1. Correct. Integrate, you get x. Differentiate, you get 2 over 2x plus 1. Correct. Then uv minus integral v du. So x times ln 2x plus 1, that's correct. Minus away integral of v du, which is x multiplied by 2 over 2x plus 1. This guy, correct. Then x times ln 2x plus 1, leave it alone. You integrate this guy. 2 times 2 is a 4. So what do you do here? You tried to, you cancel away this sign. Okay, never mind. Then you simplify this working, you realize that it's 1 minus 1 over 2x plus 1. Let me see. So here it's a x. So on top should be a 2x. Then in that case, you have 2x divided by 2x plus 1. Let me double check your long division now. 2x divided by 2x, so you get a 1. Multiply, you get back 2x. Multiply, you get a plus 1. Minus bracket. Cancel off, you're left with minus 1. Okay, then therefore your answer should be 1 minus 1 is the quotient, so put over there. -1 is the remainder. So put over there, divide by 2x plus 1. Okay, so wrong already. Over here, you never put down integral sign. You see, integrate dx. What you're doing is you're just doing long division. You haven't done any integration yet. So this should still be an integral sign. Okay?
Okay.
Then I think you didn't integrate, or did you integrate? You just forgot to put integral sign. Let's double check. Ln 2x plus 1 mod times x, you get this part here. Then you proceeded to integrate even though you didn't put the integral sign. So -1, you get a minus x. Good. Minus becomes a plus. You get ln of 2x plus 1. That's wrong. Because here there's a 2x plus 1. You need remember f prime x over f of x. That's how you get the ln of f of x modulus. You know this formula, right?
Yeah.
But the problem here is f of x is what? 2x plus 1. Can you see?
Mm.
So the numerator needs a
Half.
no. Differentiate f. You see, 2x plus 1 bottom, fx at the bottom, f prime x at the top, 1 at the top. What is f prime x here?
2.
2. Yes, you actually need a 2 here. So that means that if you need a 2 there, but you don't have a 2, so you have to purposely introduce a 2 by introducing half here and times 2 here. That's why there's a half. Can you see? Integrate this one and you get our x, but bring in the minus. Then minus becomes a plus. Well done. Then you have half times integral of this guy, which is ln 2x plus 1, but you need an extra half. Okay? Proceed. Yeah, then just miss out the half. Okay, moving on. So next one, 4f is fine. Okay, 5. This one very good. You've replaced the limits. Well done. You replace the upper and lower limits. Okay. Then what do you do next? Okay, do you do long division here? Wow, you never show any working. You can do it in your head.
Yeah, I sub in.
Okay. Can. Then you just get your answer is fine. So I got nothing to say already. Just take note that here, when you're doing definite integral, there's no more plus c. There's no more plus c. Let me show you a quick example why there shouldn't be plus c. The rule that you're supposed to memorize is that definite integral with limits, no more plus c. Indefinite, then you need the plus c. Indefinite means don't have the limits. So let me show you. Let's say I have 1 to 2 of x plus 1 dx. If I pretend that this is indefinite integral, what will I do? I will integrate integrate the insides term by term. Yeah. Then after that, I will have a plus c, right? If this is indefinite integral. But then now, because of the upper and lower limit, it tells me I need to draw square bracket 2, 1. Then I have to sub in the 2, sub in the 1. Then I put minus in between. But of course, I don't just put a 2, 1 there. I will write down 2 square over 2 plus 2 plus c, bracket. Then 2 square over, not 2 anymore, it's a 1. 1 square plus 1 plus c. But if I open up the bracket, I realize that I have 2 square over 2 plus 2 plus c, then minus I bring in. Or rather, I don't bring in everything, I just rewrite it as minus of bracket 1 square over 2 plus 1, then minus c. Agree it's the same?
Yeah.
Can. So that means that what happens to your plus c and minus c?
They cancel out.
So you're doing indefinite integral, yes. You get a plus c, yes. But it actually appears in 2 times. It appears twice when you're substituting the 2 and the 1. So the c will actually cancel each other off. That's why at the end of the day, you're just left with 2 square plus 2 minus away 1 square over 2 plus 1. You don't need the c anymore. Is this clear?
Yeah.
Can. Just remember, memorize this one from AMAX. Don't need the plus c. Okay. Wait, I should put down EG. I'm sure you know it's an example, not relevant to the question. Yeah, so that is 5 done. Just make sure you don't have a plus c. Part B. Okay, I don't know what is this. I kept on seeing this tiny little minus sign here. It shouldn't be there, huh? I think it's just a pencil marking or something. No?
I think I put minus though.
Because that would be wrong if you did put a minus. Because I see over here, I don't know if it's minus or is it equal sign. I assume it was an equal sign. Shouldn't have a minus. Let me show you. Over here we got what? X here, then cosine 2x. Okay. Then how to differentiate x? You just get a 1. Then integrate cosine, what do you get? Sine.
Yeah.
Don't need minus, right?
Mm.
Double check. Sine differentiate, you get cosine. No minus involved. Okay, so there shouldn't be a minus involved. Then, but of course, there's a 2x here, so you have to divide by 2, chain rule. So that's why it should just be sine x over 2. Don't need a minus. I was assuming that you just put an equal sign, or did you mean to put a minus there?
This one is minus sign, but I don't know why the second line got.
Yeah, it shouldn't be there, because at the very next line, the minus disappeared. Oh, so you make 2 mistakes. You assume that there should be a minus here, then you factor out the minus, and then the next line you forgot to write down the minus, so you became correct. So 2 mistakes they cancel off each other. Wow, very powerful. The minus shouldn't be there. Just take note. You already wrote down the correct integral. Just follow. No minus involved. No minus involved.
Okay.
But anyways, at the end of the day, you got the correct answer. So nothing to say. Yeah, no minus involved. Integrate cosine, just sine. No negative. Only when you integrate sine, then you get negative cosine. Is that clear?
Yeah.
Okay. Yeah, negative cosine. This one. Fussy. All right, moving on. This is the JAC prelim revision package. Let's take a look. Here, something went wrong. You got the partial fractions already, so you can rewrite this fraction as this partial fractions, and then you integrate term by term. Okay, but here x minus 1 bracket square is not. You cannot just integrate to get ln. Please look at the procedure. Remember the procedure for the summary. Whenever your denominator, you're under part C, integration of a fraction, you actually got why are you in part C? Let's explain that first. It's because you are currently having a x minus 1 bracket square power 2. Right or not?
Yeah.
Then let me ask you, when you got x minus 1 bracket square, are you under this formula? F prime over f?
No.
No, right? X minus 1 bracket square, you differentiate, is actually 2 bracket x minus 1. That you don't have a 2 bracket x minus 1 on top. So that's why it's not L. It's not under L. It should be F formula. Which formula? But before you even do that, you need to do something to the denominator. What do you need to do?
Complete the square.
Complete the square. Yes. So let's complete the square first. Here actually, yeah, I told you if you actually had a 2x minus 2 on top, then maybe it will work out as the ln, but it's wrong. So, have I shown you? I think I didn't write down the solution. I'll just show you the solution key. This is, oh wait, the solution key. I haven't sent you yet. Hold on, let me send you the file.
But I thought the f prime x, like the denominator, can be like fx to the power of n.
Fx to the power of n.
Then like the top part only
yes, correct. You can. Then yeah, then you actually don't need to complete the square. Yeah, you're correct. Yes. Sorry. Oh right, I forgot to think about that part. Yes, you can do that. I sent you the solution to the revision pack already. Yeah, let me just bring back my screen. Okay, so yes, you're correct. When you integrate the ln, you can actually. Sorry. No. When you integrate the 1 over x minus 1 bracket square, yes, it's a power n. So you bring it on top, you get x minus 1 to the power of -2. Add 1, get the new power. So -1, divide by the new power, -1. Then since this is 1x, I have to divide by a 1, which is of course not doing anything. If this was a 3x, then I have to divide by 3 because of chain rule. But here it's just a 1, so divide by 1, as good as not doing anything. Then you plus d. So this one, simplify, you actually get negative 1 over bracket x minus 1. Oh, yeah, good. So this part is wrong. I circled already. The correction should be here. You can read the solution later on your own now. Moving on. B part 1, what happened? Not correct. Reverse chain rule. Let me see. Oh, you didn't finish up. This one is okay already. Oh, wait, let me double check. LIATE, you have a trigo sign, and then you have a exponential e. So over here, right, actually, you just need to use reverse chain rule. You don't need to do integration by parts. Do you notice that if you differentiate the e power 2x, it's just 2e to power 2x?
Yes.
So that means that the integral here, you can just introduce a half and a times 2. You get 2e power 2x times sine of e power 2x dx. So what you have now is f prime x. And then over here, it's a g of f of x. Then you integrate, you just get capital G of f of x, where capital G is the integral of little g. In other words, this is just negative cosine of e power 2x with an extra half in front.
Oh.
Correct or not? Differentiate this, you get to differentiate negative cosine, you get to sine. But then chain rule tells you e power 2x, you have to differentiate. So you have a f prime x outside. Can? Yeah, that's the answer already. Yeah, don't need integration.
Reverse chain rule.
Yeah, inverse chain rule, reverse chain rule. Okay, next, B part 2. Here, I think you forgot to put a minus sign, but then you auto-correct yourself somehow. I'm not sure how, and you got the correct answer. Yeah, so it's correct. I got nothing to say. Moving on. Part 3, also correct. Nothing to say. Here, question 2, a bit funny. Correct idea, but you wrongly execute the formula. So let's take a look at this formula again. Let's look at the first one. Purple, light blue, yellow, green. P, Q, half P plus Q, half P minus Q. What's the relationship between purple, light blue, yellow, and green? Purple, the P, is just the sum. Light blue, the Q, is just the difference. Left plus right or left minus right. Here, the minus, the order matters. Left and right. Left and right. Okay? Can, huh? Good. Okay. We pick the first formula because you involve sine times cosine. The question involves sine times cosine. So what do you see? What's my left, the yellow color?
The 2.
The 2x. Then the green color, right side, it's just a single x. So that means you should get a sine purple plus sine light blue. Is it correct? 5x and x?
No.
No, huh? Yes, it should actually be if you add them together, you should get a 3x on the left, purple, and then the light blue should be a
x,
right? 2x minus x. So that's why error carry forward. Then I'm sure you know how to do the rest. I don't want to elaborate. Can? Can I do yourself? Okay, can. You can look at the solution. Then question 3, partial fraction. Sorry, no. This question I think you got confused by how to solve for A and B. Your procedure here is correct, but you got the wrong answer. I'm not sure what's going on. Yeah, because you're supposed to do that. Yes, you can x sub x equal negative half. That's fine, but it's wrong. Let me double check.
But I thought
negative half out. Your B is correct. Sorry, your B is correct, but your A is not correct.
Oh.
A is a half. Okay, let me just show you how I did it. So over here, right, what I did is I just multiply the A inside. So I get 2ax plus a, then plus b. So far, okay?
Yeah.
Then
Okay.
after that, what I do is I compare coefficients. So I look at the, what is it? I look at the coefficient of x. So here is a 1x, there is a 2ax.
Mm.
So that means 1 equals to 2a. Solving for a, I get half, not 2. Okay?
Okay.
Then your b is correct. How I did it is I compare coefficient again. Constant here is what on the left-hand side? There's no constant, right?
Yeah, don't
So
have
it's a 0. Then the constant here, 2ax plus a plus b. What's the constant?
The a plus b.
A plus b. Yes, that's why I get 0 equals to a plus b. Okay?
Mm.
Then I sub in the a with 0.5, half, and then solve for b, I get negative half. Okay? So now you sub in into the formula, you actually get half times 2x minus half. Okay, the purpose why they want to do this, it will be clearer in part B. Or actually not part B. Is it part B? Let me double check first. What question was it again? Question. Okay. Wait. Yes, question 3B. No, it's still part A. Sorry. Integral of x over x squared plus x plus 3. Yeah. So let me just bring my screen back up. So what's going on here is that you are replacing the numerator x with this expression so that you can do reverse chain rule. I think also how to save yourself before you continue is check that this expansion will not give you x. You see 2 times 2x will give you what?
4x.
So definitely there's no more x already, so the 4x cannot be reduced further. It will be a 4x, definitely not x already. Straight away you can see it's wrong. Okay. Yeah. So you have to redo the whole thing. So should I go through this or do you want to try on your own again? I mean, that's the solution. It's already quite clear.
Okay, can try myself.
You want to do it now or after class?
After class.
After class, then we can cover more. So the trick here is basically first 2 terms here, you can split up into 2. Factor out the half. And you also realize that x squared plus x differentiate, what do you get? X squared plus x plus 3 differentiate the whole thing. 2x plus 1, right? Yeah, 2x plus 1 over here. So you got f prime x on top already and fx below. That's your first fraction. So you know how to use reverse chain rule to solve that. But here you got a minus half over a fraction. Sorry, minus half over a quadratic. What do you need to do?
Complete the square.
Complete the square first. Then after that, you go and look at the formula list, see which one you can use. Okay, moving on. B part 1, what happened? This is correct. This one is wrong. Forgot a minus sign. But then somehow you auto-corrected yourself and then your answer is correct. I have no idea how you managed to do that. Okay. Okay, never mind. At the end of the day, it's correct. I'll just put a minus sign there and everything is fine. Moving on. Okay. So now, yes, you got the diagram correct. How do you know that it must be a b in between 0 and 1? It's because they gave you 0 less than b less than 1. So that means that there must be a point of intersection. If you try with a few different values of b, do you do that?
Yeah.
Yeah, like what b equals 0.1, 0.2, 0.3, you realize the graph always looks like this. There's a point of intersection, x-intercept here that's in between 0 and 1. Then what did the question ask? The question asked, I forgot the question. Let me check. They ask you to find the integral from 0 to 1 of x times modulus x minus b, where b is between 0 and 1. So integrate 0 to 1, but you realize that there's one part here at the bottom and one part here that's above. This bottom one means you'll get a negative if you try to integrate, but when you'll not get a negative when you're trying to integrate. So actually, let me think a bit. Oh, sorry. This is not good. This is bad. This is bad. No. You shouldn't put down a minus. Because over here, they didn't ask for area under the curve. Okay.
Oh.
So you just need to find that negative area, or negative area here at the bottom. They simply ask for the integral. They did not request for the area bounded between the curve and the x-axis, and x equals 0 and x equals 1. They did not request for that. They requested for the integral from 0 to 1. So the integral will have to include the negative as well as the positive. So you shouldn't put a minus sign here. Sorry, I forgot about that. Is that clear?
Yeah.
Yes, integral only, then you don't need to auto correct yourself and put down the minus and make it into positive. Only when you're finding area of under a curve, then you need to. So so this minus shouldn't be here. This wait, did I I marked it correct. Oh, so sorry. This is wrong. This should have been plus here and minus there. Then after that, this is just error carry forward. So that means your answer here is wrong and wrong. You just need to change this part yourself. Plus then minus. Then everything else simplify. Okay?
Okay.
Do it yourself. Can moving on. Question 4a. This one very long-winded. What you should probably work on is how to integrate this to get the final answer faster. Your answer is correct. Okay, just need to get the final answer here faster a bit. How I will do it is I will notice that I have my favorite 1 plus already, so I'll leave it alone. But then here you got 3x squared. Remember the format is over always 1 plus or f prime x over 1 plus bracket fx bracket square. Okay, then what you need is bracket then power 2 here with fx inside. So I noticed that the 3 don't have a square. Okay, and also maybe I should note that there's an invisible coefficient 1 in front of the something square. So here there's a 3 instead of a 1. We don't want that. So what we should do is to rewrite the 3x square as square root 3 square x square. So you get bracket square root 3x square. So that means that you actually have 1 divided by 1 plus bracket square root 3x square. Is that enough? Not enough, because here is f of x. On top, you need f prime of x. So what is f prime of x? F square root 3. So that means we need to purposely introduce a square root 3. Okay, or rather times square root 3 on top, then divide by square root 3 on your own. See? Very fast, right?
Yeah.
Just convert into something square, then multiply root 3 top and bottom. Then now that you have it in the correct format, just replace with tangent inverse. There you go. 1 over square root 3 times tangent inverse root 3x. Okay, try to learn to do it a bit faster, but your answer is correct. You decide to factor out the 3 here is a bad idea. Don't factor out 3. Instead, you should do this trick. Rewrite the 3 as square root 3 square, and then you factor out the square. Factor out the square, sort of, exponential rules, basically.
Okay.
Then don't factor out 3. Slow. Okay, moving on. Slow, don't factor out don't factor out 3. Because the 1 is already there. If you factor out 3, the 1 turns into a 1/3, which is very bad. It's already there. Yeah, okay, moving on. Part B. What do we have here? You differentiated correctly. X times e power negative x squared. Then after that, you try to integrate this. I said almost. Why almost? Oh, you tried to differentiate instead of integrating over here. Oh no. dv by dx go to v. You need to integrate, right?
Yeah.
Integrate plus 1 to the power, then divide by the new power. Not bring down the power minus 1 to get the new power.
Yeah.
You see that? You differentiated instead of integrate.
Yeah. Oh no. Okay.
No. So do I need to go through this?
Don't need. I think it was like a mistake.
Like just careless mistake. You understand the concept. Then I don't go through already. Read the solution. Let me know if you got any questions. Moving on. Question 5. almost correct. Here you left it in the U world. Do you see? You already used a substitution x equal half times e power u. You successfully converted into the u world. That's well done. But then simplify, then eventually you get to this expression, also correct. Very good. But then you need to bring the u back into the x world. Okay, bring back into the x world. If you see the question 5, right? Question 5 is starting off with ln of 2x times, then divide by x times whatever, everything also in terms of x, then dx. So you need to bring it back into the x world. How do you do that? Just need to make u the subject and then sub in. So here I did it for you. X equal half times e power u. Just bring the half over, so you get a 2x equal to e power u. Then you want u as a subject. Just bring the e over, so it's ln 2x. Okay. Then here ln 2x, you just need to sub in now. I'll leave that to you lah. You sub in with ln 2x. Here also ln 2x. Everywhere I've got a u replaced with ln 2x. Clear?
Clear.
Yeah, do it yourself. Can and 6 part 1, what happened? X equals to a sine theta, so x squared equal to a squared sine squared. Then here, okay, I don't know what happened, but your fraction here, why did it have a divided by square root a squared minus x squared? Look at the question. Look at the question. Got fraction, man?
No.
No fraction. So how come your solution got a fraction?
Oh no.
I don't know what's going on. Yeah, I got very confused.
I put 1a then times a.
Oh, right. So okay, I think I get what you're doing. But what you are doing is you are trying to write down 1 over a times just square root. There's no fraction. Right? This is what you're going for?
Yeah.
Okay. Also not very useful because you're integrating with respect to x. You want the f prime x, right? What is in this case, I think what you're seeing is the f of x is underneath the square root. When you try to find f prime x, you're differentiating with respect to what letter?
X.
Yes, so x is the variable. That's why you differentiate with respect to it. A square here is just a number. You can think of it as like 5 square or 7 square or 6 square or 8 square or whatever. It's just a bunch of numbers. Then if you put in an a here, that's all that you can do. You realize that it's still not the derivative of a square minus x square. Derivative of a square minus x square will be 0 minus 2x. So it's just negative 2x. This is still not the derivative. So that means you cannot use reverse chain rule here. Okay? There's no point to doing that, multiplying and dividing by a. They already told you the technique. Use substitution. But actually, what I found out is that your answer here was actually correct. I think I marked wrongly. Should be correct. Okay, can I just demonstrate to you how I solve this question from the start?
Okay, can.
Can. Okay, can. I think it's easier. So let's just redo this entire question. Here I correct, and then I'll add a page. Then I got 6 part 1. Let's take a look. Okay, this comment should be below. Yeah, so let's just start from scratch. So question 6 part 1. Let me copy down the question first. So I have x equals to a sine theta. Then I have the integral. Sorry, I know you cannot see the screen. I'm just copying the question first.
Okay.
Okay, so the part 0 to this one, there's a part 1 and part 2. This one part 0. You want to show that this integral equals this integral. So what do you know about questions where you have a show and there are subsequent parts? The subsequent parts, so let's say that you couldn't solve this, you couldn't show it, then what do you need to do in your subsequent parts?
Just use the what's given.
Just use the formula that's given. Please be exam smart. Use the formula that's given. Don't just give up on the entire question. Get some partial marks. Use the result given. Okay, but let's just show this is how we get this. So x equal a sine theta, you did it correctly. Okay, maybe I should give you a procedure for how to do integration by substitution. Okay, maybe I'll call this step 1. Deal with substitution. So x equals to a sine theta. You differentiate it, what do you get? Dx by d theta, right?
Yeah.
How you get the order? This is like y equals to a sine x, so dy by dx. But we are changing the letters to x on the left, then theta on the right. So x on top, theta below. Function in terms of theta. So differentiate, you get, just factor out the a first, then differentiate, you get cosine. Okay, good. Then you want to convert from, you see a dx here? You make dx the subject. So maybe I'll call it step 2. Make dx subject in terms of this one actually optional. Sometimes it's sometimes you may not need to do it. In terms of what is it? In terms of theta. Okay, theta here in this case changes according to question. So contextualize contextualize your formula. So you get dx equals to a cos theta d theta. Then in this case, you realize that here got dx, here got dx. You can immediately replace with a cos theta d theta. But then now you want to substitute in the step 3, limits. Change limits or bring from x world into the u world. Okay, usually I would say x world to u world is because the integral they usually give us as u equals something. But here in this case, what happens is that your x become your x is still x, but now you are bringing it into the theta world. U is not u is theta in this case. So that means that we need to, how I would like to do it is I like to just be extra sure that I am currently in what world. Currently you are in the x world, right? Because dx and x, the limits also x haven't replaced. So I write down x equals just to confirm to myself, convince myself I'm in the correct world, what world I am in. Okay, I am currently in the x world. So it's optional, but I like to do this. It's not wrong. It's not wrong to write it. Then after that, step 3 is to convert the limits. So x equals a, then I'll draw an arrow like this. To remind myself I am converting, like a bit like chemistry, chemical reaction, convert into a different form. Reactant product. So now we're gonna change from x into the u world. How? Use the formula law. I'm sure you know how to do that. So you get a equals a sine theta. Then divide by a on both sides, you get 1 equals to sine theta. So this is the critical angle, critical value, 1, 0, -1. Straight away, you must just use a graph. Sine looks like this. Let's call this a theta axis and a y axis. Then this is y equals sine theta graph. So when y equal to 1 over here equals to 1, how to solve for theta? Must be the intersection over here, or rather the x coordinate of the intersection here, which is what?
Pi over 2.
Good. Pi over 2. Okay, next one, you get x equals to, what's the lower limit? A over 2. So we write down a over 2. This implies a over 2 equals to a sine theta. Divide by a on both sides, you get half equals to sine theta. So you get a half. This one, exact value, I hope you know, is just pi over what? This one can sign inverse calculator, but then they won't give you the pi. So you need to divide by pi on your own. So what's the fraction here? Pi over what? Try sine inverse of a half, then you get a bunch of decimals. Then after that, you divide by pi.
5/6.
Yes, pi over 6, 30 degrees. Okay? 60, 30, this is 2, this is 1, this is square root 2. Oh, square root 3. Huh? Pi over 6 is 30 degrees. Yeah, so anyways, you get the two limits already. So that's why your A max trigonometry is important here. If it's not strong, then you will struggle here. Theta equals to, what's the upper limit? Notice I made sure that my upper is on top and my lower is below. So that when I read off, I see theta on top, theta below. So theta on top, theta below, I just copy exactly. So because I have done it before many times, I write down pi over 6 here and pi over 2 there. I mix up the order many times. So this is how I prevent it. I make sure that I copy exactly top and bottom, top and bottom. So you convert your theta on top, theta below. You won't get confused already. Top and bottom, top and bottom. I hope you are not confused.
Yeah.
Okay, carry on. Then here, I advise you to not skip this step. What I strongly recommend you to do is to not directly substitute in with the theta version of the answer. I want you to show some working so that maybe the examiners can give you some partial marks. Okay? Because I noticed that you keep on directly substituting with the expression in terms of theta, and then you end up being wrong. It's not equal because of some small mistake there. So what I want you to strive for is accuracy. Here, how to get an accurate answer that's a bit long-winded, it's very simple. You see square root, you copy the square root. You see a square cannot replace, right? Just copy down the a square. You see minus, you copy down the minus. Just do it, be patient. Then you have an x square, it's bracket, bracket, square. What is x again? X equals, remember, a sine theta. So that means we just put in a sine theta. And then dx, do you leave it as dx?
No, must sub it.
No, remember, convince yourself that you are now we travel to theta world, travel to another country. So you need to have your passport stamp. Here's your stamp. Here's your stamp. You cannot have dx. You cannot bring your subway into Australia. No, you'll get fine. The dx will have to be, what is it? A cos theta d theta, right?
Yeah.
You bring your remaining half-eaten subway. You'll just get fined. This will be wrong. Please convert into the local currency or something like that. Yeah, X turn into theta. SGD turn into Malaysian ringgit. Something like that. Okay. Then you realize that this is multiplication. So maybe I should write it down on the same level. Make it look neater. Okay, then you can proceed to simplify. Here, once you write down this accurate step, then you can do all the trigonometric identity as scratch work, and then you simplify straight away. And that's what I usually do. I don't want to clutter it too much. If not, I keep on repeating integrals theta equal pi over 6 over pi over 2. I have to keep on repeating theta equal pi over 6, theta equals pi over 2. Yeah, very tiring. So that's why I focus on this inside and I do it at the side. So step 4. Actually, I should mention this sub x sub dx directly without simplifying. Okay? Do you understand what I mean by without simplifying?
Yeah, I don't go and expand everything.
Yeah. Very simple one. You see square root, you copy square root. You see a square, you copy a square. You see minus, you copy minus. You see x square, this one no choice, have to do something funny. A sine theta bracket bracket square. You see dx, change currency, change into the local currency. So a cos theta d theta, change to from the x world into the theta world. Likewise, the limits also need to change. Maybe I should also mention that sub x, sub dx, and sub the limits. Or convert the limits. Convert or sub. Okay, 3 things. You must have a checklist. X, did I change the x into theta world? Yes. Did I change the dx into the theta world? Yes. Then did I convert or substitute the limits from the x into the theta? Yes. How do you convince yourself that you are in the theta world? Make sure you see the theta 3 times. Theta here, and theta here. 1, 2, 3 times. Clear?
Yes.
That's why I usually write down theta equals and theta equals to remind myself, oh, I am converting from x world into theta world. I have successfully converted from x into theta.
Mm.
You don't need to write this. Actually, if you never write, it's fine. But I like to do it so that I can remind myself that, oh, yes, I forgot. If I continue writing down a and a over 2, I will check, oh, I need to write theta equals. Once I write down theta equals a, if let's say I forgot to calculate pi over 2, I write down theta equals a, I'll be like, wait a minute, x equals to a. Oh, yeah, I forgot to convert. How can x be equal to a and theta be equal to a at the same time? Cannot be. I forgot that. Then I can remind myself. Correct or not? So have the habit of writing down this theta equals. Hopefully, it will help you to prevent calamity and accident. Huge
can
mistake.
write in the exam, right? The expression
This is correct. This is perfectly fine. It's just long-winded.
Okay.
My style, my long-winded style. I like it, so I can remind myself I am in the theta world now, and be accurate. Because right now you know how to integrate already. It's just that you keep on making careless mistakes here and there. You forget this step, forget that step. Yeah, and very wasted. So I'm just coming up with measures to help to prevent careless mistakes. Okay, then this is step 4. And step 5, what do? Step 5, you have to simplify the integrand. Okay, simplify the integrand. So what do I mean? So scratch work, maybe I'll just box it up over here. We'll try and simplify this entire expression. So square root of integrand is referring to the thing that's in between the tauge and the d theta. So integral a square minus a sine theta square, that's just a square sine square. Just do it step by step. I know straight away you can factor out, you can see that the a square can factor out, but just do it step by step. Times a cos theta. It's worth the investment in time. Trust me. Then you see square root. I know you can see straight away how factor out the a square, you get 1 minus cos square, 1 minus cos square, replace with sine square, sine square, a times sine, bracket square, cancel off with the square root, then you get a sine theta. But just do it step by step, so you can guarantee you don't make careless mistakes, because that is your problem right now, careless mistakes. So factor out the a, not just a square. You get 1 minus sine square theta, close the bracket, times a cos theta. Next step, square root again, a square inside. You realize what's 1 minus sine square? Cosine square, right? No. This formula here, not in the formula list, not in MF26. You better memorize this.
Okay.
But the more useful form, of course, is to make cosine square the subject, and then you realize it's equal to 1 minus sine square. Or you can also make sine square the subject, but this is the relevant version. So 1 minus sine square is cosine square 2 times cosine square theta times a cos theta. A, you realize square and square. So you can factor out, I need more space, equals to square root of a times cosine theta, bracket square, times a cos theta. Just be patient and write down a cos theta all the way. All right?
Okay.
Then what happens? Square root and square cancel each other off neatly. You are left with a cos theta times a cos theta. What's that? A times a is a square. Cosine times cosine is cosine square theta. Good. Now that we are at cosine square, we can sub back in. But I just sub back in to make it. I can continue simplifying, but I just like to sub back in at this stage, because it looks simple enough. Pi over 2, then a square cosine square theta. Don't forget d theta. Here the integrand is this light blue part without the d theta. And I simplified it as a square cos square. Is that clear?
Yeah.
Can, huh? Okay. Yeah, then in that case, we get d theta to be what? D theta to be just d theta, leave it alone. Okay? And I can remind myself again, am I in the theta world? Theta here at the limits? Check. Theta in the integrand? check. D theta, not dx, check. 1, 2, 3. Make sure you got these 3 checks. Limit, integrand, d something. Theta, theta, theta. Clear. Okay, have a checklist. 3 things. The x, the dx, the limits. X, the start x means the integrand must be in terms of x. Must be in terms of theta, not x. Right, theta, theta. Okay, moving on. So now you got cosine square. Can we integrate cosine square? So we get cosine cube over 3?
No.
No, please make sure you got that. For trigo, right, whenever you have power 2, let me show you the ultimate list again, right from the very, very beginning. When you have squares involved, part 2 squares. Remember this?
Yeah.
Standard functions, trigonometric, part 2 squares. You need to use either of these, the double angle identity. Okay? So I'll just use this 1 plus cos 2x over 2 dx. Okay, but here instead of 2x is 2 what? 2 theta, because it's a theta. Okay, good. Then the limits still write down pi by 6, pi by 2. At this stage, I drop the theta because I already know I'm correct. So I'll just drop the theta. I know that I already convert into the theta world. Or should I just write it in? Just write, not wrong. In case you forget. Okay, then how do you integrate this? The half you can factor out. Then you got integral of 1 plus cos 2 theta d theta. I know, very slow, very slow. Factor out the half. Too slow for you. But I strongly recommend that you do it because can prevent careless mistake. I'll factor out the half first. Then you integrate 1 by 1. Can see? Factor out the half.
Yeah.
Okay. Then just copy down the half. Integral. Copy down again. So most of the time you're just copying the previous line. Maybe at this stage we can skip a step. We can just not skip a step. We just jump straight to the next step already. Integrate 1. What do we get? Theta.
Theta.
Integrate. Because we're in theta world, so must be theta, not x. Integrate cosine. What do we get? Sine. But wait, it's 2 theta, so we copy down 2 theta. But you need to divide by
2.
Good. What's the limit? Pi over 6 bottom, pi over 2 on top. Okay, then you just sub in half again. Then this one again, I notice you always jump straight to the final answer. I strongly recommend that you write down the correct answer first. As in, you just manually substitute it in first, 1 by 1. Just do it. So what I mean is, equals to a half times some huge fraction here. Then you have something minus another thing. Correct or not?
Yeah.
Then over here, you write down sub theta equals pi over 2. Over there, you write down sub theta equals pi over 6. Then it's accurate. Because if you simplify straight away into some fraction and you get it wrong, I get extremely confused, I don't know if you understand that you're supposed to sub in, and then minus. This demonstrates understanding. Simplifying shows you know how to use a calculator. A primary school kid also knows how to use a calculator. That's not what we are testing you in A-levels. Just sub in. So that means pi over 2 plus sine of, just literally, don't even do any mental sums. I know 2 times pi over 2, 2 cancel off is a pi, but just write it down. Just do it. Show every working so that you can get some method marks. Then after that, because you keep making careless mistake, that's why you must try and get as much method marks as you can. Show them you understand this. Then it's just manually copying everything down into calculator to get a 3SF answer. But usually the question will request for an exact answer. So no choice. When you got pi involved, you can't really use a calculator. You need to do it sort of manually. So let's just see how we can simplify this. So half there, bracket there. Then we got 2 times pi over 2. Simplify. 2 and 2 cancel off. You're left with a pi on top. So sine pi, in that case, that would be a 0. Remember sine?
Yeah.
And 0. Good. Then 0 divided by 2 is just a 0. So we simplify it down to bracket. Pi over 2 plus 0, close bracket, minus pi over 6 plus, same thing over here, 2 and 6 cancel off, become a 3. So pi over 3. What's sine pi over 3? This one, no choice, must use exact value. 60 degrees.
Yeah.
Yeah. So what's your answer? I'll show you the trick. Calculator at the side. Let's see. So we want to take sine of, what is it, pi by 3. So your calculator by default, if you press mode, you'll see that the where is it, radians, where is it, here, radin degree, can see?
Yeah.
Yeah, it's already automatically selected to be radians. So now we're going to proceed with radians calculation. Sine of what we want, pi over 3. So find my pi first, it's over here. Divide by 3, close the bracket, enter. Alternatively, you can also alpha 1 or alpha y equals n number 1 for n/d, enter to get the fraction to type in our pi over 3. But that's a bit slow, so I didn't do that. I just did a divide symbol. So this answer 0.866, can we use it? Cannot, because we want exact value. We need the exact value. It's actually square root 3 over 2. Please remember the table of values. I also explained this before. It always involves square root. So in order to help us recover the exact value without memorizing, here's a special trick. You can take the previous answer, then you square it, power 2. What do you get? 0.75. Oh, very confusing. My fraction very weak. I need to go back primary school. And never mind, calculator helps you. Press math, then number 1 for fraction, press enter, enter. You get 3 over 4.
Oh.
So that means the original is the square root. In order to undo the square, we take the square root of 3 over 4. You can simplify it straight away as square root 3 over 2. Yes?
Yeah.
Alternatively, it's to use the table. The table says what? The table says what? Okay, I'll do a quick table here. 30 degrees, 45 degrees, 60 degrees, also known as pi over 6, pi over 4, pi over 3. I draw this table before for you already. I'm sure you know this. I'm just recapping. Sine, cosine, tangent. It's always divide by square root 2. Oh, sorry, divide by 2, divide by 2, divide by 2, divide by 2, divide by 2 for the first 6. Then you take square root, square root, square root, square root, square root, square root. Pattern here is 1, 2, 3, 3, 2, 1. Okay, sine is an increasing function from 0 to 60, 0 to 60 degrees. 0 to 60 is here, this part here. Over here. So it's increasing, that's why it's 1, 2, 3. Cosine is the other way around, so it's decreasing. That's why it's 3, 2, 1, count down. Then tangent, you just have to divide. Tangent 30 degrees is 1 over square root 3. Then you have a 1, then you have square root 3. If I'm not mistaken. Yeah. Just take sine divided by cosine. Okay? Can exact values? Okay. Okay.
Yeah.
Can. Moving on. So now that you have numerator being square root 3 over 2, so what we have now, maybe I write it at the side in case I'm confused. Square root 3 over 2 divided by 2. So wouldn't that just be, if I bring the 2 down, or I can think of it as the primary school KCF. Square root 3 over 2 on the top, divide by 2 at the bottom. Divide means what? 2 is the same as 2 over 1, so I can simplify as keep, change, flip. And I get square root 3 over 2 times 2. Alternatively, you can see it straight away, divide by 2, bring down, become times 2. So it's just square root 3 over 4. Okay, then you can replace square root 3 over 4. Can?
Okay.
Then you continue simplifying. Here you got half a pi minus 1/6 of a pi. You can just use a calculator straight away. Okay, this one I'll just do divide. 1 over 2, then you minus away 1 over 6. Just use a calculator. You know, right? This one?
Yeah.
Then you get what? Oh no, decimals. How? Never mind. Math, number 1 for fraction, enter. Then you get 1/3. If you are using the Casio calculator, you have a SD button. standard to decimal. You can use that. So you get a 1/3. 1/3 what? Don't forget a half. Don't forget a square bracket. Don't forget the equal. 1/3 what? Half a pi minus 1/6 of a pi. How many pies left? 1/3 pi. I'm waiting for you to say pi, huh?
Oh, okay.
Right. Correct or not? Just pi over 3. I'm just trying to calculate this. I'm trying to show you how to not make careless mistakes. Just use calculator. Don't need mental sums. Okay, no need mental sums, but I mean, you can use a calculator to help you. Then you got minus square root 3 over 4. So write down minus square root 3 over 4. Square bracket. And then you get pi times half times in. So 2 times 3, 6. 2 times 4, 8. Answer. Can?
Okay.
Actually, not the answer, yeah. They want what? They want a square over 24. So did I do something wrongly? A square over 24. Did I do something wrongly? Yeah. Yes, I did. Let me just double check. I don't know where I did wrongly. I realized my mistake. Over here, when I substitute in, I use formula cosine square, get 1 plus cos 2 theta over 2. But then I didn't use the a square. Actually, let me just double check. Should it be a plus or not? Is it a plus? Yes, it's a plus. So I actually need to put in an a square. So sorry. I need to factor out an a square. A square. A square. A square. A square. Then I have an extra a square in front. Then this is the correct answer, but you need to convert it into this format over here. Let me just copy and paste it so I can have a reference. Yeah, okay. So is it the same? Should be, Mic test, are you still there?
Yeah.
Okay, good. Sorry. Then the 6 and the 8, we need to make them into a 24, right? So how do we do that? We just need to convert a square times, how do you cut 6 to 24 times 4? So 4 pi. How do you get an 8 to 24? Times 3, so 3 root 3. Then you simplify, you get a square over 24, bracket 4 pi minus 3 root 3. Then we get our final answer. Can? Okay, shown. That is part 0. We still got part 1 and part 2. Let's go. So part 1 and part 2, what do you have? Let me see the question again. Oh, no. Let me close my. Yeah. So, what was I saying? Lost my train of thought. Yes. Part 1 is asking us to sketch the ellipse. Okay. So the one minor mistake that you made over here is that you forgot to convert into this format. I think you forgot about this format. Do you remember graphing techniques? This guy?
Oh, I forget already.
Oh no. Okay. Basically, you need to complete the square if you got linear terms in x and y. Okay. So over here, do you have linear terms in x and y? Like 1y or 7y power 1? You have?
No.
Don't have means you don't need to do completing the square. Okay, leave it alone. So you get 3y squared equal to a squared minus x squared. Let me show you how I did it. What I did is I bring my minus x squared over, so I get 3y squared plus x squared. Can you see?
Yeah.
My y's and x are always on the left side. Then what I do next is I need to memorize this. My right side must always be a 1. So a squared, how do I convert into a 1? I divide by a squared on both sides. Can?
Can.
Then I simplify a squared over a squared, 1. Divide by a squared, I can split into 2 fractions. So 3y squared over a squared, it's really just y squared over a over root 3 bracket square, right? Okay, that's a bit difficult to see. Can see straight away.
Kind of, but
I would recommend that you work it out at the side. So over here, let's see how I thought about it. So 3y squared over a squared, here's one way you could interpret it. You can rewrite as 3 over a squared, the constants, multiplied by y squared. But multiplying by y squared, it's really the same as y squared over 1. So now you got the y squared on the numerator. remember ultimately you need the format of y minus q bracket square over b square. Sorry, my 2 looks like a q. I meant to write a 2. Oh. Yeah. Okay. So what you have is a y square on the top already, but then you actually need a bunch of number square, a b square at the bottom. So how do we get the b square? Let's see. 3 over a square. You can rewrite it as 1 over, then you flip the fraction around. Yes?
Yeah.
So, there you go. You got the a square over 3 at denominator already. So you got 1 multiplied by y square, then a square over 3 times 1. So that means you get y square on top, a square over 3 at the bottom. Clear?
Yeah.
So the variable on top, then number below. A square, a is just a number. Then you continue simplifying. How? What you realize is that 3 is the same as square root 3 square. So a square over 3 is the same as a square over square root of 3 square. Which you can factor out the square now. A over square root 3, bracket, square. Can?
Can.
Okay, good. That's how we got it. Then likewise for x square over a square, this one is simpler. You don't need to simplify anything. It's just x square over a square. So now that you have it in the format of x minus 0 and y minus 0, you know the center must be at 0, 0. That's exactly what you had. Okay, then over here, these two numbers, the number directly below x tells you the radius in the x direction, or the radius of the ellipse means this part here or that part there. So the radius in this case is what? A, right? For in the x direction. Can you see?
Yeah.
A in the x direction. So that means this distance here must be a at negative a, in terms of the coordinate. So your answer here is wrong. Minus a square over 3 is wrong, and positive a square over 3. But the vertical distance, you got it right. Square root a square over 3. Yes. Yeah, correct. Square root a square over 3 is the same as a over square root 3. Yes. This guy. Correct. Okay.
Okay.
Do you need recap on hyperbola and sketching the other guy circle?
Yes.
Okay, let's do it now. All right. Crash course recap on still got graphical transformations. Oh my. Graphical transformation is just y equal d plus c times f of bx plus a. You just need to know this. As for linear, this is a linear transformation. Up, down, left, right. Up, down, left, right, involving stretching as well. Then you still got what the y equals 1 over x graph, y equals square root x graph, y equals to dy by dx graph, y equals to dy by dx graph, the derivative graph or the f prime x graph. Yeah, anyways, all these are the second half of graphical transformation. The first half that you should already know is the conic sections as well as rationale functions. Do you know how to graph rationale functions? Just use GC.
Yeah.
I mean, and long division. Yeah, then you get a quotient plus remainder over divisor. Then you got horizontal asymptote, vertical asymptote, diagonal asymptote. You know this time? This kind of thing. Yes, then I don't go through that one. I'll just go through this conic sections. So first one, conic sections, you already know from Amex, it's a circle. Circle, the key thing you need to realize is that the coefficient of x squared to y squared is always a 1. Equals to, let's say, radius, let's say 1, let's make it complicated, 5 square. Then that means your circle will be centered at 0, 0. And then you have a radius of 5. Here is 5, here is negative 5, here is positive 5, here is negative 5. I'm sure you know our circle equation. Yeah, then the top half is actually just, if you make y the subject, you get 5 square minus x square, take the positive square root. The bottom is y equals negative 5 square minus x square. This will be required when you're trying to do integration, when you want to integrate the area under the curve. Which is what I meant to go through today, but no time already. Okay, let's just continue on circle. Let's say I have another example. Let's say x squared plus 2x, and then I have plus y square plus, let me think, 6y, and then equals to 10. What's the equation of the circle? First step is to realize that just now we had just x squared, just y squared. But now we got extra x, extra y. What do you need to do? Complete the square. So here you got x plus 2 divided by 2 is 1, bracket square, then minus 1 square. I purposely choose an even number so that I can have a nice divide by 2. But usually it won't be so nice. If it's a 3x, then this will be 3 over 2. Then it will be minus 3 over 2 square. I'm sure you know completing the square. I don't need to elaborate, right?
Yeah.
And then same thing here, 6 divided by 2 is 3 squared with brackets, then minus away that same constant square. Again, I purposely chose 6 so that I can divide by 2, get a 3. Nice numbers. Equals to 10. Equals to 10. Then what do? Leave this alone. The squares, leave it alone. Make sure that both are plus signs, both are plus signs, and both are 1:1 ratio. Make sure you got that. Then you bring it over. So 10 plus 1 square plus 3 square. Type in a calculator, what do you get? 1 square is 1, 3 square is 9, 20. But that's really just square root 20 square, correct?
Yeah.
So that means that square root 20, if you simplify, you realize it's really just square root 4 square root 5, which is 2 root 5. So it's just 2 root 5 bracket bracket square, which means that the radius is what? You see, just now got 5 square, radius is 5. Here got 2 root 5 square, so the radius is
2 root 5.
Exactly. Radius is underneath it's always the square root of the right hand side. Square root of a square, you just get 2 root 5. That's why you get the radius. Then the center, center is where?
-1, -3.
Very good. Yes, so -1, -3. Then just draw the circle. So plot a point here, -1, -3. 2 root 5 is, I'm not sure what the radius is. I'm just going to pretend it's something like this. Then maybe shrink it down a bit. Yeah, something like that. Then -1, -3. So that means it's where would the origin be? -3. So somewhere here, I guess. You can use a GC to confirm. All right, that's a circle. Can? Circle, okay?
Can.
Okay, moving on. Now we're gonna look at the next example, which is, let me start a new page. Next one will be on ellipse. So number 2, ellipse. So what is an ellipse? An ellipse is really just a oval shape, symmetrical as well. That's what we call the major and minor axis, but I don't need to know. Just need to know there's the long one and the short one. Okay? Long in the x direction. Not really long. You can't tell whether it's long or short until you see the equation. This is the one such axis, and that's the other axis. This is in the y direction, that's in the x direction. Clear?
Yeah.
The key thing about an ellipse is that you will always get it in the form of x minus p bracket square over, let's say, a square, then y minus q bracket square over b square, then equals to 1 on the right hand side. All right, for the circle equation, I should give the general form. It's actually x minus a bracket square plus y minus b bracket square equals to r square. So in that case, your center will be a comma b, then your radius will be equals to r. In general. Okay, then for ellipse, this is the general form. You have to mention, oh no. You have to know that the center is where? Center is P comma Q, and then you got the I don't want to give a formal name. I'm just gonna call this the horizontal, the x radius, the x radius. What do I mean by x radius? This one, parallel to the x-axis one. This one, it's A. Then the y radius, maybe I'll highlight it. Light blue, y radius. Pink color is x radius, is a B. How do I know that? Because I see y here, what directly below is a B. Then x here, directly below is a A. So let's do a quick example. Oh yeah, by the way, the key key thing to take note is that the coefficient of x squared and y squared not equal. Okay, I should phrase it properly. Wait a minute. Yeah, something like that. Coefficient of x squared is not equal to y squared. So let's see an example. Let's say I have 3x squared plus 2y squared equals to 5. Okay, wait. I don't want to pick such an ugly number. Let's say I get a 10. Also not so nice. Let's say I pick 5. Okay, nice. Notice straight away that the coefficient is different. 5 and 2.
Yeah.
Straight away, I also see that there's a plus sign for both.
Yeah.
I should also mention. And the sign is of x squared not equal, same as. Okay, when they have the same sign, plus and plus, then you will get an ellipse confirm. Let's see how we can convert it into this format. First thing you need to realize is you need a right-hand side to be a 1, but here's a 10. So what do? Divide both sides by?
10.
10, exactly. Right-hand side, 10 over 10, get a 1. This one, 5x squared over 10 plus 2y squared over 10. Can we simplify it? Just do a bit of algebra and you realize, oh, can. I already just now demonstrated with a more complicated example. So here should be quite simple. 5 over 10 is a 2. Then plus 2y squared over 10, you get y squared over 5 equals to 1. Clear? So what's the circle? Is it just what's the x radius and y radius? Is it just 2 and 5?
Or square root 2 and square root 5.
Very good. You must force out the square. So you get a square root square for the 2 and the 5. That means you can now sketch the graph. Square root 2 is bigger than square root 5. So that means that your y radius is longer and your x radius is shorter. So you must look something like this. Oh, by the way, where's the center?
0, 0.
0, 0. X minus 0 here, y minus 0 here. So it's over here. Then you got a major radius, longer y radius, and then you got a smaller x radius. Then you just draw the oval shape like this. Like this, just try to make it smooth. Okay, then after that, this one will be square root 5, negative square root 5, and the other guy will be positive square root 2, negative square root 2. Okay, that's it. Then let's try a more complicated example. This is example 1. Example 2 now. Example 2 will be a bit more complicated. Why? Because we will now introduce some x terms. So let's say you got 3x squared plus, don't pick 3, let's say pick 5. 5x squared plus 2x plus I don't know 4y squared plus 7x. No, 7y. Okay, should I make your life difficult by introducing odd number, or should I make it even?
Odd.
Keep it odd, difficult, so you can demonstrate. Okay, can. Then you just add some constants and whatever. Then on the right side, let's say I put a 8. I don't know, random number. Wow, this is gonna be very ugly. But let's just continue. So what do you need to do? Straight away, you see that the coefficient it's no longer a 1. What do? No longer a 1. So you must do the special kind of factorization. When completing a square, you need to factor out the coefficient of x squared first. Make sure you get a monic x squared. Monic means what? MONIC. Coefficient is 1. It's just a special word you don't need to know. Then you get 2 over 5x. Same thing here. Y squared and y. So you factor out the y, you get 4y squared plus 7 over 4 equals to 8. Clear so far?
Yeah.
If there were constants, like let's say, for example, plus 5 here, then you just bring over, then you get minus 5. Let's just use that. Then you get a 3. Okay, fine. Then 5 bracket x squared plus 2 over 5x. How to simplify? You just divide by 2, then you get 1 over 5 bracket square, then minus 1 over 5 bracket square. Done. Plus 4 bracket y plus, I see plus, I just bring down plus 7 over 4 divided by 2 is 7 over 8 bracket square minus 7 over 8 bracket square, close the bracket, equals to 3. Factorize, you get 5 times, x, multiply in, you get 5 times x plus 1 over 5 square minus away 5 times 1 over 5 square plus 4 times y plus 7 over 8 bracket square minus 4 times 7 over 8 bracket square equals to 3. Okay, good. So what do you notice? Variable, variable, constant, constant. Bring over the constant. What do you get? What do you get? Minus 5 times whatever becomes a plus. Minus 4 times whatever becomes a plus. Just bring over. Can you see the animation? Do you see the animation?
Yeah.
Oh no, it got cut off. Wait. Okay, I rescued it. Yeah, so that's what we get. I need to add a new page, no space. Continuing, what we get now is a bunch of constants. Can you type in the calculator for me? What do you get?
501/80.
Good. Okay, so equals 501/80. So yeah, that's why very ugly numbers are. So what do you need to do now? Make what equal to 1?
The 501/80.
Yes, you have to divide by 501/80 on both sides. On both sides. So you just get to 1 straight away. But when you divide by 501, isn't that the same as multiplying by the reciprocal? So times 80 over 501. Same thing now. So that's what we're going to do. Multiply by 80 over 501 times what? Times the whatever was on top. So copy and paste. Okay, simplify this. Then you just times in now. Times in the 80 over 501. Wow, pain. Okay, let's just do it. So let's say we get this guy times 5 straight. Times 5. Then you multiply by this guy. And then you get plus, I get a plus 80 over 501 times 4. Then times the y plus 7 over 8 bracket square equals to 1. Now you can rewrite this. Let's just type this into the calculator and simplify first. 80 times 5 divided by 501. I get a 400 over 501. Everything else copy. 80 times 4 divided by 501. 320 over 501 times y plus 7 over 8 bracket square equals 1. Then what you realize is that you can bring it to the bottom. How? The coefficient here. Let me show you. 2 over 7x. Do you agree that it's just x over 7 over 2?
Yeah.
Yes. Then how? This one. Bring down. What do you need to do?
501/400.
Very good. Correct. Plus, same thing with the other guy. Y plus 7 over 8 bracket square. Then bring it down to the denominator of 501 over 320. Equals to 1. Are we done? No, we still need to have the square root square. Square root square. So now let's just calculate numerically what the value is. 501 over 400, take the square root. 501 divided by 320, take the square root. It's approximately 1.11915. This one approximately 1.25. Okay, so this is bigger. All right, so that case, how do you draw? Can you tell me where's the center first?
The negative 1/5, negative 7/8.
Well done, good. Yeah, should be a minus, then negative 1/5. So yeah, correct. Then how about the x radius? By x radius, I mean like you got this part here. If you have this part here, what would it be?
501/400.
Yes, correct. And how about the y radius?
501/320.
Yeah, correct. Good. Then now you should know how to sketch the curve. So let's just so which is longer? We know that the 501/320, which is the y radius, is longer. So that means our shape must look something like this. something like that. Okay, the center is here. Then what's the center? -1/5, comma, -7/8. Then you can just mention, wow, this is very bad. Let me try and make it a bit nicer. Okay, not much improvement. Yeah. So the center, take note, this is not the y-axis because it's -1/5, comma, -7/8. So it's probably somewhere here. Roughly speaking. Let me check the numerical value of -1/5. That's around -0. That's -0.2. -7/8 is -0.875. (0.875). Then in that case, where would it be? Is it here? Let me think. -0.2, then -0.2, then -0.875. Okay, this is shorter, this is longer. That means it should look something like this, I guess. Roughly lah. The y-intercept, I'm also not sure. I need to calculate to be extra sure. Okay. Yeah, then that's how you sketch it. That is an ellipse. We're not done yet. This is still number 2 ellipse. We still have a third version, which is what's the name?
Hyperbola.
Hyperbola. Let's go. So hyperbola. Oh, sorry. I realized I didn't give you another example. Then maybe I give a quick one. Let's say this is 0 plus y minus 0 squared, and then divide by, let's say that the x radius, I make it bigger. So let's say 5 squared, and this one is 3 squared equals to 1. Here is an ellipse, but it will look horizontal. Right, the center is 0, 0. And then the radius here is 5. Then the y radius here is 3. Just to give an extra example of a horizontal, a flat one. Maybe this one, sorry, I forgot to label a few more points. This length here is the 501/320. This is -501/320. Actually, that's not true. Because it's with respect to the center. This distance here is -501/320, but you start from -7/8. So you should actually be -7/8 plus, then -7/8 minus. Is that clear?
Yeah.
How about this x? How about this x coordinate? This point here. What's the coordinate? Like along the same horizontal. What's the y coordinate?
The negative. 7/8.
Yes, correct. It should share the same y coordinate because it's along the same horizontal. You know what points I'm referring to, right? The 4 points of an ellipse.
Yeah.
Those points also. Likewise, this other point, what's the y coordinate? Also -7/8. Clear?
Yeah.
How about the x coordinate? X radius is 501/400. So this distance here is 501/400. It's to the left.
Is the -1/3 minus
1/5, sorry. Handwriting.
Minus 501/400.
Good. Then the other guy is?
Plus the
-1/5.
501/400.
Well done. Okay, now you understand already. Ellipse. Okay. Ken? Moving on. Hyperbola. So let's say we got hyperbola. You just need to make sure that the so what we had just now for ellipse, coefficient of x squared not equals to coefficient of y squared, and the sign is the same. Now it's exactly almost exactly the same. It's just that they are both not equal. So hyperbola is not harmonious. They are not equal. Not equal for the coefficient as well as for the sign. Then you will get hyperbola. So maybe I should draw a quick. I should just mention it here for Oh, I copied the wrong thing. Let me just copy this. No time to go through application. Oh my goodness, that was supposed to be a plan. Okay. Sine not equal. So let's just draw a quick table. Circle, ellipse, hyperbola. So what you need to know is the coefficient or the value, the magnitude of the coefficient of x squared and the magnitude of the coefficient of y squared. Then there's a symbol in between. Let's just draw a diamond and put a question mark. Then diamond in for circle, diamond is equal to sorry. I should just fill in the blank. It should be equal. Okay. What do I mean by that? What I mean is you must replace the diamond there with equal. Coefficient of x squared equals coefficient of y squared. For ellipse, it's not equal. For hyperbola, it's not equal. Then how about the sine? The sine of x squared and sine of y squared. I did this. Oops, I got extra line. Sine of y squared. Sine not as in SINE, the Tokaso, no, it's the plus minus sign. Right? Plus minus. For circle, it must be a plus. For ellipse, it must be a plus. Hyperbola, it must be minus. Or actually, it's not equal, sorry. Equal, and not equal. Okay?
Yeah.
Equal, not equal, then not equal. So let's see an example. So I have 3x squared minus, let me think of a good number, 6y squared equals to, let me think of a good number. I don't want this, I want 15. Equals to 15. Okay? So what should you do first? Same procedure as ellipse. Do you see a linear x term? A linear y term? Power 1?
No.
So do you need to complete the square?
Don't need.
Don't need. Then what do you need to do to the right hand side? Turn into a 1. So divide by
15.
So both sides divide by 15. Same procedure as ellipse. Then because they are in the same family, I guess. So now you can split it up as 3x squared over 15 minus 5y squared. 5y squared over 15 equals 15 over 15, which is 1. Divide. Then you get x squared over 5 minus y squared over 3 equals to 1. Now, can you see that the plus belongs to x squared? Plus belongs to x squared. Remember, their sign must be not equal. Sign not equal, right? So one is plus, the other is minus. So can you see that the plus is belonging to the x squared?
Yeah.
Yes, then that means your x shape, your hyperbola, I hope you remember, I do something like this. Can?
Yeah, can.
Then you need the asymptotes. Here, how to find asymptote? Very simple. Pretend that your 1 here is a 0. Okay? Pretend that your 1 is 0. So asymptote. Sorry, oblique asymptotes, the diagonal ones. Oblique means diagonal. It's just a fancy way of saying not straight. Not horizontal, not vertical. Here, maybe I should also mention, when I see plus sign, then I know that the shape must be like this. Okay, how do I know? You see x here, then you see it looks like the hyperbola looks like x. Okay, can. Then oblique asymptote, you just have to pretend RHS equals to 0. I'm giving this rule because it's a result from taking limits, which is technically not in your syllabus. You only need to roughly know it, and it only applies when you're doing some sequence and series. But I think your sequence and series still quite weak.
Yeah.
The table question you still don't know how to form.
Yeah.
I'm just gonna skip it. I'm just gonna ask you to memorize this. Right, RHS equals 0. Then you solve for. Then after that, right, what you do is you replace the 1 with 0. Then after that, your next step is to make y the subject. So making y the subject, what do I get? I get y squared over 3 equals x squared over 5 first. Then I times 3 over, I get y squared equals 3/5 x squared. So y equals to plus minus square root of 3/5 x squared, which is plus minus square root 3/5 x. Technically, it's square root of x squared, which is modulus of x, but we already put down plus minus in front, so it absorbs the modulus. Do you get what I'm saying? It should be like this, right? Split
Yeah.
into 2 square roots. But square root x squared by definition, when you square something, it's always positive or 0. Then you take the square root, it just goes back to a positive. So it's actually just equal to absolute value of x. Definition. But here, if you replace it with a a modulus of x, then you can open up as plus minus x. But in front already have plus minus. So you don't need to do it again. You can just simply write it as x. Can? That's already a plus minus. So drop. Basically you can just pretend the square and square can cancel off. Or half and 2 cancel off to become 1. Yes?
Yeah.
Yeah, good. So that's the equation. Then you just need to now draw the graph with the asymptotes. So let's copy down the equation of the asymptote first. And then can you figure out what's the center?
0, 0.
Yes, very good. Because x minus 0, y minus 0, just like the ellipse, just like the circle. Then how about the asymptotes? It's over here, huh? Asymptotes is over here. Maybe I'll just summarize it neatly like this. Asymptote. Okay, then you just draw the y-axis, x-axis, asymptote, asymptote. Okay, I should probably use dotted line and try to be neat. Hold on a second. Just make it symmetrical. You just use a ruler and write dotted lines, broken lines. Then in this case, there's a s. So what shape should it be? Positive x squared. So what shape should it be? Can you draw on the screen? Oh no! Oh no! Oh no! Oh no! I already gave the answer here.
Oh.
Positive x squared means it will look like a x. Positive associated with x, it looks like a x, so it should be here and here. Is that clear?
Oh, I think I memorized wrong.
Oh no, follow the plus sign, plus x, then it's just an x shape. Okay, can then just make it symmetrical. Then you want to find out the x-intercept also, okay, just have to sub y equal to 0. Solve for x. Yeah, so on and so forth. I'll leave that to you.
Okay.
Yeah. Yeah, sub y equal to 0 means this guy go to 0, then I'm sure you know how to find x, right?
Yeah.
Make x. Okay. That's one example. Let's move on to a more complicated example. Now we have just now this example 1, no linear x, no linear y. Now example number 2, we're gonna introduce linear x and linear y. And to make your life difficult, maybe I'll also introduce a y square. Okay, maybe okay, I don't make it difficult first. Y square minus x square equals to 1. Okay, let's say we got this. So can you tell me straight away what's the center?
0, 0.
And the right hand side already equal to 1, right? So do we need to divide anything?
Don't
need. So in this case, let me see. Can you tell me what is? Oh, sorry. Let me double check first. Okay, I should mention something. This one sub y equal to 0. It's actually quite important. Following the pattern of the ellipse. Sorry, I'm going back to example 1. Does 5 replace with square root of square? 3 replace with square root, then square. So what you should realize is that if you sub y equal to 0, you end up with plus minus square root of 5. Can you see that?
Yeah.
So that's why over here is a negative square root of 5 and positive square root of 5, which is the same as the x that we have here. Yeah, but if you sub x equal to 0, you realize that x equal to 0. yeah, if you sub x equal to 0, you can't solve this equation now because you end up with 0 minus y squared over 3 equals to 1. So times negative 3 on both sides, you get y squared equal to negative 3. If you try to take the square root, you'll have to introduce imaginary numbers, which is a very bad idea. Huh? Yeah, we don't talk about imaginary numbers in graphing. Right? So that's why there's no y-intercept.
Yeah.
Can yeah, that's just a side note. Not so important. You know how to find x and y-intercept. Just sub y equals 0, x equals 0. So you got center is 0, 0. Can you tell me what's the asymptote? What's the procedure to find the oblique asymptote?
Make y squared the subject.
No, right hand side first. Must turn into
a 0.
That's your first step. Then you make y squared the subject. Yes, so y the subject. So y squared equal x squared, then y equals to plus minus square root x squared, which is just plus minus x. Yeah. Okay, y equal plus minus x. Then you can just draw the graph now. I'm trying to make it look nice. These two guys I want broken. Solid line here. Okay, x, y origin. Then what do we have? What is the positive sign here? Beside the plus sign is beside y or x?
Y.
So look, I draw big for you. Plus y. Okay, wait, I use a thicker font. Y. Doesn't it look like if you draw a bit cursive, your y, some people will have an extra tail like this when you write down a y. Isn't that just a hyperbola shape?
Oh.
Can see or not? Very important. Positive in front of the letter y. That's why your hyperbola looks like this shape here. So that's why over here it should be this shape, Okay? Unlike your x. If it's plus x, then your shape is x. If it's plus y square, then you get, If it's plus y square, then you get these two shapes. Can? Okay, so now we try to draw the graph. It should be symmetrical. The distance from the origin should be the same. Okay, and also make sure that it's approaching the asymptote. You know that?
Yeah.
Maybe I try to make it more accurate. Sorry, let me try. Very, very close to asymptote. Then you go towards the center. Then you curve and make it symmetrical. Then you try to make something that looks like the mirror image. That's assuming I drew my asymptotes accurately. I just randomly guess. Yeah, close enough, close enough. Okay, something like that. So can you tell me what's the two intercepts? How to find? Sub what with 0?
The x equals to 0.
Then I'll leave you to solve it. Sub x equal to 0. I'm sure you know how to do it. Okay. Can? That is the case where you have no linear terms. Now we try with linear terms. Oh my goodness. I don't have time to go through integration application. How to assign homework. Okay, let's just go. So you got y squared plus 2y. I'm not gonna use odd numbers. I'm gonna make it so long-winded unnecessarily. Plus 2y plus, it should be opposite sign. So let's say minus 3x squared plus 8 equals to 6. Let's just make it 2 So first thing you should do is to realize that here got linear terms involving, I meant to put 8x. Here got linear terms involving y and x, involving x squared. Okay, actually before that, let's just start from scratch. Actually, you're seeing this question from scratch and you didn't know it's a hyperbola. How do you identify that it is a hyperbola straight away?
The sign is different. The y
and the magnitude of the coefficient is the number in front. 1, 3 is also different.
The square.
the square. So you get y plus 2 divided by 1 is 1 square. Minus away 1 square. Okay, here you got a minus. What do you do? I like to factor out the minus 3 first. Can I just quickly change this number into a 9 to make my life easier?
Sure.
Actually 6. 6 is easier because 3 times 2. Anyways, let's just pretend you didn't see that. It was always a 6. You factor out a negative 3. What do you get? X squared minus 2x. Can? Coefficient of x squared is a positive 1. Then after that, you simplify. Okay, let's just simplify this. You get x squared minus 2x. We're going to simplify this into x minus 2 divided by 1. 2 divided by 2, you get the answer 1. Then bracket square minus way 1 square. Can? Okay, then now you multiply back in the negative 3. Multiply in. What do you get? Copy and paste the whole thing, but then the negative 3 goes in. So negative 3 bracket x minus 1 square. Then negative 3 times negative 1 square is positive 3. So plus 3. Can?
Can.
Then after that, what do? You leave all the squares alone. Leave all the squares alone so that you can now bring the constants over. Minus 1 square becomes a plus 1 square. Plus 3 bring over becomes a minus 3. So you simplify. What do you get? 0. Oh, that's a 0. That is not good. Huh, why is there a 0? Means I planned the question wrongly. Can I just change this quickly into a 5? Sorry. Yeah. Then you get a 3. Okay. Sorry. Yeah, that was an impossible question just now. It's not even an equation. No, it's just a linear line. But yeah, that's not what I want to bring up here. So change to a 5 plus 1 square minus 3, which is a 3. Good. Then we can simplify the left-hand side. Continue simplifying. What you realize? You actually always need the x minus. Oh, I forgot to mention the general format. Should be either positive and negative or negative and positive. Then you get x minus a bracket square. I should be consistent. X minus p bracket square over a square plus y minus q bracket square over b square equal 1, or x minus p bracket square over a square but with a negative in front, and then you got plus y minus q bracket square over b square equals to 1. Here straight away, if you see a plus sign, then you know that you'll get a shape like this. Here straight away, when you see a plus sign in front of the, oh sorry, wrong direction. Let me just try again. Sorry, speaking too fast. Okay, when you see a plus sign in front of the y, then you get a y shape.
Yeah.
Okay. Yeah, then if you see a plus sign in front of the x, you'll get a x shape. Asymptote. Okay, can. So now, is it in the fraction and plus minus fraction format? No. Is it equals to 1 on the right side? No. So which one should you deal with first? Should you try to make it into a fraction first, or should you try to make it into a 1 first?
Make into 1 first.
Make into 1 first. Very good. So then you make it into a 1 divided by 3. Actually, both ways will work, but this is the fastest way. Then you end up with y plus 1 over 3 minus divide by 3. Then you get x minus 1 bracket square over 1. Is this clear?
Yeah. Can.
Okay. See, by dividing by 3, you introduce a fraction. So you didn't have to try to purposely make this into a fraction or anything. Or anything funny. Faster. Okay, can. Then now sketch the curve. How? Wanna try drawing? Maybe I draw the x and y axis for you first. What do you need to first identify?
The center.
Which is?
-1. 1 and -1.
Good. X is 1, then y is -1. Maybe I throw away the x and y axis first. Later, then we draw. You just need to identify that there's a 1, -1 center. What's the next thing you need to identify after center?
The asymptote.
How?
must make the y the subject. Make the right hand side 0.
Then you make y the subject. Okay, so let's do it together. Y plus 1 bracket square over 3 minus away x minus 1 bracket square equals to 0. Then you make y the subject. How? Can bring the x minus 1 square over, you get positive.
Yeah.
Then next sign, y plus 1 equals?
Take square root on both sides. So it's square root 3.
Plus minus square root 3 bracket x minus 1 square. Then simplify is plus minus?
Square root 3 times x minus 1.
Very good.
Minus 1.
Minus 1 plus minus square root 3 bracket x minus 1. This one, I would recommend you to, let me think. Yeah, I recommend you to expand this out. So what you get is y equals -1 minus square root 3 x minus 1, or y equals to -1 plus square root 3 x minus 1. Then you simplify. So what you end up with is a minus square root 3x minus 1 minus becomes a plus, so plus square root 3. So -1 plus square root 3. The other guy would be positive square root 3x. And then you got a -1 minus square root 3. So here you see plus root 3 minus root 3. Okay?
Yeah.
Okay, then you can start to draw the curve. Sketch the graph. You should realize that both of these graphs must always pass through a certain point. What point?
The center.
The center. So you got drung. Okay, so let's just sketch. Maybe you try sketching. Yep, and the other line. Good. Okay, so from there you have your two equations already. Positive square root 3x should be the top or bottom?
The positive one is the top.
Okay, good. So that means that we will end up with, maybe I label y equals to, just copy the equation down. Copy and paste. Oh, sorry. Then the other guy is y equals to the negative square root 1. Okay, then how to draw the curve? Remember the equation? Try. Good. Okay. Then yeah. Wait. Oh, okay. I just draw it in for you. So you get this curve, and then you get that curve. Can you find out what is this turning point here and there? X coordinate should be what?
2.
Sorry.
Oh, the x coordinate is 1.
Yes. How about this one? It's also
1.
So since you know that x equal to 1, can you find y?
Can.
Then just do it on your own. Just sub in x equal to 1. You realize it's 1 minus 1, 0. Then this guy just goes to 0. Then you solve for y. You end up with square root 3. Is it right? Sorry. Sorry. No. What I mean is, this distance here will be square root 3. So then what happens if you believe me that it's square root 3? You start with -1, then you go up by square root 3 units. So what's the units here? So what should be the y value here?
-1 plus square root 3.
-1 plus square root 3, and the other guy is -1
minus square root 3.
Exactly. Okay, good. Yeah, then you know how to sketch already. Okay, that's it for crash course on ellipse. I'm sure you can work it out on your own for the x square version.
Yeah.
Yes, can. Okay, can. Good. Okay, come back to the paper. Oh my goodness. Yeah, so graphing technique, eventually you just need to change the y value here. Then how about the, what do you call it, the integral? Let's go back to this question. Let's see the question first. Okay, we're still at question 6. We found the integral a squared over 24 times whatever. Part 1, we also sketched the curve already. Part 2, R is the region enclosed by E, the line y equal to x, and the positive x-axis. Find the exact area of R in the form of k times pi a squared. So let's take a look at the your working, what went wrong. So over here, wait, let me just make the screen a little bigger. So over here, what you should see is that there's a blue triangle and a yellow circle shape. Can see or not?
Can.
So blue triangle. Do you know why I split out as a blue triangle? It's because of this point here, the point of intersection. At this point, right, we are asking you the area bounded between the y equal to x, the curve, as well as the x-axis. So you should realize that there's only one region, which is here. And you realize that at this point of intersection between y equal to x and the ellipse, there is a sharp point. Like at the top graph here, above the x-axis is straight line. But then for the next half, after this point, after this vertical line to the right of the vertical line, it becomes a curve. Can you see that?
Yeah.
So that's why you have to split it up. Are you aware of how to split it up? Can this one? Just draw a vertical line.
Yeah.
Then you get a blue, then the goal of this question is to find the area of blue triangle plus the yellow weird shape. Here, what you did is you found the area of the weird shape. You integrate from a over 2 to a, and you didn't give me a reason for a over 2. You understand,
but how
right?
do
This
I
point
know
here.
it's A over 2?
You didn't know, then how do you put this down? You just tikam. You just guess. Wait, you didn't understand why it's a over 2. Okay, very simple. You just need to solve them simultaneously. Y equal to x and the equation of the ellipse. Then you get the x coordinate of this point. Simultaneous equation.
Okay.
Then you can get a over 2. Let me demonstrate this. So here you got the equation, let's call it 1. Then here you got y equal to x, let's call it 2. So you can just sub 2 into 1. Also, everywhere that had a y, I replace with x. So I get 3x squared equals to a squared minus x squared. Bring the x squared over, you get 4x squared equal to a squared. Divide by 4, you get x squared equal to a squared over 4. Take the square root, then you get plus minus square root a squared over 4, which is plus minus a over 2. Plus minus a over 2 means over here is a over 2. Maybe I label on the graph. Here it's positive a over 2. This other point of intersection also has a x coordinate that will be negative a over 2. Understand?
Yeah.
It's these two guys. Maybe I highlight here, here. Then you just need to, after you figure out it's a over 2, what you did here, you integrated correctly. What you found is the yellow area. Can you see my color coding? The yellow circle shape quadrant thing. It's this answer here. So it's incomplete. You forgot to add on an area of a blue triangle. Can see?
Oh, can.
Can okay, then just find the area of the triangle on your own. You know the base is just a over 2. How about the height? How do you find the height? This is y equal to x. This is x equal to a over 2. What is this height? Do you realize that sub in x equals to a? Do you understand that the vertical length here is really just the y coordinate of this point? Are you aware of that fact?
No.
Like, how do you get x comma y? It's really just horizontal length then vertical length. Like for example, if you have a point here, 2, 2, what does it mean? It means you travel 2 steps to the right and then 2 steps to the top, right? That's how the x and y coordinates are read, right?
Yeah.
So same thing over here. If you want the vertical length, isn't it just how many steps you travel on top? Like how many steps you have to take? 1, 2, 3. Then that will be your height. So it's really just your y coordinate. Are you aware of this fact? The y coordinate of a point is the vertical distance from that point to the x-axis.
No.
Now you know. Please remember this. You need to know this for application of integration. Okay, understand? This is vertical height. Then later on, you'll start drawing rectangles like this. See before? Please say yes, no. Have seen before? You need to find out the area of, this is the, I guess, one of the more difficult questions. for application of integration. Okay, then anyway, so we need to find out the x and comma y. So what is my x here? Oh my, okay, what? Okay, I don't know what happened. So the x here is a over 2. Then the y leh, just have to sub in, y equal to x. So that means your y is also a over 2. Correct or not? Sub x equal a over 2, then you get y equals a over 2.
Yeah.
Then there you go. You found your height already. This height here is worth a over 2. This horizontal length here is worth a over 2. How to find area of triangle now? You got base a over 2, height a over 2.
So it's half times a over 2 times a over 2.
Exactly, that's all. You just need to find that. So you can read the solution, find. Okay, moving on already. Then you just need to add on. Your answer is incomplete. Almost there, almost there. Just need to add on the half times a over 2 times a over 2. Okay, then let's look at question 7 here. Oh, next question 7. Question 7, by means of the substitution y equal 1 plus square root x, show that this integral equal 2 plus 2 ln 3, ln 2 over 3. So let's see your working. So you remember to replace the limits. Well done. You did the dy by dx, okay. And then you make dx a subject, but you didn't write down dx. Never mind. You understand now, Ken. So this equal to dx, that's fine. You sub in, this is correct. Oh, your answer is correct. Okay. Then moving on. Part 2. Now part 2 is asking, hence find the exact value of this integral. Okay, so you already integrated 1 over 1 plus square root x. So definitely you would want to involve that 1 over 1 plus square root x in your integration by parts. I think you can see this one is quite obvious. There's algebraic on the left and logarithm on the right, correct? Then you definitely want to use integration by parts. I guess, maybe. Let's see. So yeah. Okay, let's just see. What do you do? Okay, yes, you did integration by parts until this step so far. uv minus vdu. This one minus integral of vdu. So far is correct. But over here, you made an algebra error. Okay, you had a 1 over here, which is wrong. 1 here is wrong. You see, what you did, actually, I am quite confused. I think what you did is you cancel off 2 root x with 2 root x and this become a 1, is it?
No, I split up the thing.
Split up. Take note that you can only split up when there's a sum on the numerator. When there is a sum on the or difference in the denominator, you cannot split up the denominator. Let me give you a quick example. Without algebra, let's say you have 5 times 1 over 5 plus 3. So are you saying it's 5 over 5 plus 5 plus 1 over 3? Is it the same?
No, but I that's what I did.
Yeah, so definitely not. Doesn't make sense. The numerator is the one that can be split up. If the denominator is 5 plus 3, you split up as 5 and 3. No way. No. Oh, okay. I learned a new kind of mistake. Never seen before. Okay, Ken. No. You do not split the denominator up when there's a sum or a difference. Okay, likewise, like 1 over 2 plus 3 or 2 minus 3 is also not the same as 1 over 2 minus 1 over 3. No such thing. Okay, so what you should have done here is to not multiply in the 1 over 2 root x into the 1 plus root x. What you got here is correct. What you should have done is to just take 2 root x, multiply by 1 over 2 root x times 1 over 1 plus root x, right? Minus integral of v du, right? So you just take this 2 root x here, you take this bunch of nonsense here, and then you don't multiply yet, don't simplify. What you realize if you don't simplify is that 2 root x can cancel off. You see that? Factor.
Yeah.
Cancel off already, then you're just left with 1 over 1 plus root x. I'm sure you know how to integrate this. Hopefully. No? Yes? No? Yes? No? Yes, you do. Why? Because look at the question from part 1. Look at what we're trying to find. Look at the question. Is it the same?
Yeah, it's the same.
It's the same. Then you know how to integrate. Just that there are limits. Because I just didn't write down the limits. 1, 4. Sorry, should put a 1, 4. 1, 4. Yeah, so just use part 1. Use part 1. Then read the solution the provided solution for a more exact answer. Okay, Ken, moving on. So question 8. This one, wow, what happened? Here, okay. First thing is you forgot to change limit. That's a serious error. You got x equal ln 2, x equals 0. You bring into the u world, you never change. Are you aware?
Yeah.
The limits, the integrand, and the d. You change from dx to du. Good. You change from e power x to u power whatever. Okay, good. But then the limit here, not so good. You did not change from the x world into the u world. Okay, that's your first mistake. Second mistake, okay, not a mistake, but here is an algebra shortcut. When you got u minus 2 cubed over u minus 2, it's really just u minus 2 cubed times 1 over u minus 2. That's just u minus 2 power 3 over u minus 2 power 1. You can cancel off. Then you're just left with u minus 2 to the power of 3 minus 1, which is u minus 2 square. Oh, then your work would have been a lot simpler. But never mind, you proceeded with binomial expansion, it's fine. But here you never change the formula. You just blindly copy down the A. You should substitute with U. Okay? Power 2, U power 1, U power 0, so on, so forth. Oh, not just A, but never mind, later on you substitute in, you wrote down the correct variable U, so it's fine. All is fine up to this step, except for the limits. Error carry forward. Then something very horrible happened. You did the long division. You did it correctly. You got the quotient. You got the remainder. But your conclusion was wrong. Can you see? 2u plus 8 and u plus 8. Terbalik.
Oh, yeah.
Your quotient should be u plus 8. Your remainder should be 28u plus 8. Oh? So very wasted. You just got the correct solution, but you didn't get the correct conclusion. So that's why your integration is wrong. Error carried forward. I don't mark the rest. Okay?
Okay.
Can just check the solution for the answers. But you got it. Your technique is correct. You just need to be careful with the long division. Don't mix it up. Quotient is on the left side, then the remainder is in the numerator of the fraction. Remainder is the bottom guy. Stays at the numerator of the fraction. Qx plus rx over dx. Quotient plus remainder divide by divisor. Divisor is the thing you divide by, the denominator. U square minus 2u. Okay, moving on. Let me stop me if you got any questions.
Okay.
Okay, so over here got 8b. What's the question? I can't remember. 8b, sketch the graph of y equal e power x minus 2, state for 0 less than equal x less than equal 2, state the exact value of x where the graph crosses the x-axis, then hence find the exact value of ln k such that integral 0 to 2 of modulus e power x minus 2 dx equals to integral e to e power root k of 1 over x ln x dx. Okay, Ken, your answer is correct, but you never continue. Why?
Which part is correct?
This is correct. Then you need to show, right? Okay, wait, hold on, let me double check. There's a k involved. Okay. Yeah, so oh right, you only did the first half, sorry. No, not entirely correct. You got the left hand side, right? Your goal is to find the exact value so that integral 0 to 2 of modulus e power x minus 2 dx equals to something. You evaluate the left hand side correctly, but you should have continued, should have continued to evaluate what exactly this value is. Right? Then you get some value, but then that's the left hand side only. The right hand side, you still got integral of e to the power of e power root k 1 over x ln x dx. Okay, so for this one, let me just go through the solution. Hold on a second. Where is it? Here it is, and this one. Can you, oh wait, I need to resume, sorry. Can you see my share screen?
Can.
Can I? Okay, just to speed things up, I'm going to use the solution. So here is the solution. So when y equal e power x minus 2, you got the graph over here. You drew it correctly. You also found the x coordinate correctly to be ln2. But then when the graph crosses the x-axis, yeah, okay, x equal ln2, okay, whatever. Then this integral equals this integral is what they want. Then the goal is to solve for k. So what you realized is the left-hand side is whatever you found. This is correct. Good. Well done. Oh, negative because it's below, and then positive because it's on top.
Showing anything. I only see the question paper.
Oh, sorry. Wait. Oh, okay. I forgot to minimize. Let me adjust this. Hold on a second. Sorry. Is it better now? Can you see my screen?
Yeah, can. Okay.
Sorry. Okay, so you have the solution here. Y equal e power x minus 2. Then you got ln 2 here by subbing y equal to 0. Then you want to show, no, sorry. You are given that this equation is true. You want to solve for k. Then what you do is you evaluate the left-hand side integral. You get this guy here, but you never continue to simplify, which is a bit funny. I don't know why. Okay, but anyways, the right-hand side, this one you need to simplify. What you do is the x, right, you bring on top, so you get 1 over x. Then you realize 1 over x is the derivative of ln x. Denominator here is ln x is f of x. Numerator there is f prime of x. Agree? Yes, good. Then therefore you get ln of modulus of ln x. Is this okay?
Can.
Can, but then you must sub in the upper and lower limits e power root k and lower limit e. How about the left-hand side? How did they get this? You just integrate, integrate e power x, you get back e power x. Integrate minus 2, you get minus 2x. Square bracket and minus outside. Then you put in the lower and upper limit, 0 to ln 2. Then same thing for the other guy. But you replace limit with ln 2 and 2. Can so far?
Can.
Then after that, don't forget minus sign outside, bracket, bracket. Then you just sub in the upper and lower limits. Then you simplify to, do you understand why this is 2? E power ln 2. They will cancel off. They are inverse functions, right? Remember inverse functions?
Yeah.
F of x is e power x. Fx equals e power x. F inverse of x is just ln x. So every time you put f inverse, it's just equal to x. That's a rule. But f inverse is actually e to the power of ln x equal to x. So no matter what x it is, you will just simplify back down to x. Essentially, e and ln cancel off. F and f inverse cancel off. You get back to x, get back to x. So e and ln cancel off, you'll get back to x. In this case, x is 2. So that's why this is equal to 2. That's how we got a 2 here. Okay, then the rest, do I need to go through this part here, left-hand side? Sub in x equal to ln 2, sub in x equal to 0, minus. Sub in x equal to 2, sub in ln 2, then you minus.
Yeah, I think no need.
Okay, so I will trust this part of the solution. How about the right-hand side? You also sub in, no? So this one maybe right-hand side I go through. Ln modulus of ln e power root k minus away ln modulus ln e. Let's simplify this. Ln of e, what happens? What's f inverse of f of x? It's just ln of e power x. What happens to f inverse? Sorry, f inverse f.
They cancel out.
They cancel out to leave behind
X.
x. Yeah, so this is x equals to ln of e power x. So again, ln and e is x inverse functions. Even if you swap it around, you'll still get back to x. They will cancel each other off. Then you're left with x. So here, cancel each other off. You're left with ln modulus. What are you left with? Ln and e cancel off. What are you left with? A mic test, can you hear me?
Okay.
Ln and E cancel off, so you are left with, can you tell me?
Square root of k.
Square root of k, exactly. Do you understand?
Yeah.
Can, huh? Okay, then after that, you minus away ln of ln e. This one you can, oh, this one can simplify. What's ln of e?
1.
Yes, it's just 1. So now you got modulus of 1. Modulus of 1 is what? Just 1, no? So what's ln of 1?
0.
0, very good. So this means you get a minus 0. Then what's ln modulus k? Just leave it alone. Ln modulus root k. Did the modulus disappear at any time? No, but here, square root, you need to know that it's always positive. Do you know that? Square root is always positive? Square root is always positive?
Yeah.
So that means because it is always positive, that's why we can drop the modulus and change to round bracket. Clear?
So must change.
Yeah, change to round bracket.
Okay.
Yes. Of course, it's implied here the solution they didn't give round bracket.
Oh.
Oh, that's how they got a ln bracket root k minus 0 to be just ln root k. And then the left hand side, should I go through?
It's sub in.
Yeah, just sub in, right?
Yeah.
Okay, can so you believe this answer is correct? Okay, good. Let's just trust this solution. You can work it out on your own. Try. I'll try. Then let me know if you're confused by anything. Then here you got ln of k power half. Because its square root is the same as power half. Then you just bring down the power half. So you get half ln k. Then what you can do next is you can just multiply by 2. Just multiply by 2. Then you get this as your answer. So what did the question ask for? Find the exact value of ln k. So we are done already. That's your exact value of ln k.
Oh.
Okay.
Okay. Okay.
Yes. Good. So moving on to question 9. Here, this is what we call piecewise functions. Have you seen? Have you done it already? I can't remember.
No.
I haven't. Okay. Okay. Piecewise functions. Oh yeah. Okay. It's already 11:30. Okay. I marked this one as well. Let's just go through this. Okay, this is fine. Question 1. Yeah. Wait a minute. Let me think a little bit. Should you have a minus here? Oh, wait, sorry. We are finding the modulus of this function, is it? The integral of this modulus of this function, is it? Question 1.
This one is area, I think.
Is it area or modulus? Let me think. I can't remember.
I did the application questions.
Right. Correct. Let me think a bit. Let me find the question paper first. Okay, so over here, without use of calculator, evaluate this integral. Oh no, wrong is this one. Area. Okay. Yes. So for area question, right, you need to if you are using the original function without the sorry, this one they're asking for this original function, you find the area in between. So this area and that area. When you want to get a area, it's always positive. So that's why you have to purposely introduce the minus. Yeah, so this is correct. Okay. Let me just go back to that question with the modulus B on. I'm a bit question 3 part 2. Let me see again. If I can find it first. Where is it? Yeah, 3b part 2. Let me see the question again. So you're integrating from 0 to 1 of x multiplied by modulus x minus b, and you drew the graph already. So actually, the graph of x times x minus b, it looks x times modulus x minus b is like this, right?
Yeah.
Okay. Then what we want to find? We want to find the area from 0 to 1, which is sorry, I drew the graph wrongly. The y-axis should be here. So you actually want to find the integral from here to here, which means you actually want this part and this part. Yeah?
Yeah.
But then if you draw x times x minus b, it would actually be x times x minus b is just a happy face. Like this. So
Yeah.
if you try to find, so this integral requires you to find this pink color region and this pink color region, which both happen to be above x-axis. So it means you're expecting a positive and positive, right?
Yeah.
Then that means that if you try to take x times x minus b without the modulus, and you try to integrate from 0 to b, you get the area that's underneath the curve, which will be negative. So, but you are expecting positive, so you need to force a negative in front, right? To bring it back in, you need to add in an extra minus sign. If you try, this current blue color function is y equal x times x minus b without the modulus, right? Because it's positive x squared minus bx. Positive x squared must be happy face, so it must look like this.
Wait, I cannot see again.
Oh my goodness, sorry. Oh. I forgot to show the screen. I'm so sorry. That's my fault. Let me try again. Okay. Let me try again. Sorry. When you are, this is the this guy here, the red color graph is the y equal x times modulus x minus b graph. Oh, everything above x-axis. Yes. Then
Yeah.
we are trying to find the integral. The question was this guy, integral from 0 to 1. So that means we are trying to find this pink color region from 0 to b and then b to 1. This pink color region and that pink color region add together, right? Yes?
Yeah.
Good. So this first region here, it is above or below x-axis.
Above.
So if you try to integrate x times modulus x minus b from 0 to b, are we expecting positive or negative for the first region? 0 to b.
Positive.
Could be positive. So we are expecting a positive answer. But over here, if you decide to use x times x minus b, the x times x minus b graph, which is a positive x squared, is a happy face. This region here, from this is b, from 0 to b, is it above or below x-axis?
Below.
So the answer, if you try to integrate from 0 to b of x times x minus b, is will it give you a negative or positive value?
Negative.
Negatives, which is different from what we want. So that's why you need to times -1 to bring it back into positive, right?
So why I cannot put
So
the
that's why I was wrong. Sorry. Your answer is correct. I'm so sorry. I am so sorry. Your answer is correct. Good. This is correct. I was correct the first time I marked it. Oh my goodness. Yes, it's correct. I am so sorry for marking it wrongly. The answer is correct. Yes. Yeah, I just remembered that while looking at the modulus in the recent question. Kenna, sorry for that. Clarified already. Kenna, your answer is correct.
Okay.
Okay, Ken, moving on. So back to what question? Back to this question. Yes, your minus sign here is correct because we are trying to find area, no longer just integral. Okay, so this minus is correct. Okay, question 1 is done. Now, for question 2, please remember the formula for area. It's always x equal to happy face to x equal happy face. Left limit small to big. Okay, small to big. And it's always top graph minus away bottom graph. Sorry, can I just drink some water? Mic test. Okay. Can you hear?
Okay.
Okay, so top graph minus away bottom graph. And take note that every time with a minus, there are an invisible pair of brackets after the minus sign. All right, top graph minus bottom graph. So let's take a look at this function. I enlarged it for you. I hope it's big enough for you to see. Can see or not? Big enough, huh? Okay, you have top graph and you have bottom graph, right? Can you see? Red color is top graph, pink color is bottom graph. You can draw these blue color vertical lines to help you to see who is top and who is bottom. Can? Can, Then in that case, how do you find the area? Can you tell me? Now that you know it should be top minus bottom, can you form an integral now? This is 1, 6. This is 2, 3. Integral from x is which one? Is it 1 or 6? Who is x?
The 1.
Here 2, 3. Who is x?
The 2.
So here your limit should be what to what? Bottom should be.
Bottom is 2.
No, you always go from left to right. Let's go 1, 2. Bottom here should be.
1.
Then the top here should be
2.
Yes. You didn't know that? This is from Amex. Oh, actually this question is from Amex.
Oh.
Yeah. You need to know this. You cannot be wrong about this. So now you know the formula top minus bottom. So what should it be? Can you tell me what to write here?
The 9 minus 3x minus 6 over x.
Dx. That's your answer. Then you can just key in a calculator. But here, what do you do?
Oh no.
Wrong order. Why? Why did you put 6 over x here and minus 9 minus 3x?
Because I labeled the equation wrongly. So I follow what I labeled.
Oh my goodness. Oh, I didn't see that. Okay. All right. Just remember y equal mx plus c is a straight line. So you know this in sec 1 already. So yeah, it should be here, not there. Just don't blah blah. Oh my goodness. Okay. Oh, so you just label wrongly. Okay. No, misunderstanding. Top minus bottom, you understand. Okay, then how about here? Yeah, see, top minus bottom is okay. But then something very scary happened. Your limits here should be x equal. But what do you choose? You chose 0 and the square root 2 over 2. That's the y coordinates. What should it actually be?
The x, the 0 and 0.5.
Yes, correct. Oh, you understand now?
Yeah.
Careless mistake, please say. You're not misunderstanding, right? You need an x,
Yeah.
Because here is dx, so your limits must also be x, your lower and upper limit. Okay?
Yeah.
Can now? Wrong. Should be the green one. 0 to 0.5. Okay, do your own correction. I'm not gonna go through this. Then how about this one? Again, x coordinate pi over 4, y coordinate root 2 over 2. You did top minus bottom. That's good. Top minus bottom, okay. But the limits, what should it be?
The x, the
lower one should be
over 4.
Yes, correct. 0 and pi over 4. Okay, is that clear?
Yeah.
Can So your graph will always look something like zoom. This is x equal to A, this is x equal to B. This one is A, question mark, B, question mark. I don't care what's the question mark. I will just want you to focus on the x coordinate. Let's say the top graph here is okay, I use red color for top graph. What was the color I used? I can't remember. Let me see. Okay, pink color for bottom graph. Okay. Let's say that this is y equals to x squared plus 10. Let's say that this is square root of x. Let me just double check the graph first, in case this cannot be solved. So what would this be? Oops, sorry, let me just move it to the right. Yeah, something like that. Okay, so you got x squared plus 10, then you have a square root of x. So second square root x, let's just draw the graph. Press on to stop it. Press window, maybe not window, zoom standard. Okay, x squared plus 10 is a bit too tall. Okay, that's a bad idea. Let me just change it to oh no, x plus 1. And oh, what's going on? Why does it keep moving? 0.5x. Let's hope it works. Just to make things speed up a bit, I'm gonna change the window to lower resolution. Okay, still doesn't work. Let me think of a better example. Can you think of an example of a curve that looks like this? Okay, actually, this is quite okay. You know what? I'm gonna use a more powerful software to help me. I'm just gonna use Desmos. Sorry. Okay, let's just play around with some functions. Then you got y equals, let's say I have ln x. Does that work? Okay, lower a bit, -1. Maybe I'll just +3 and this one +2 +1. Okay, close enough. Yeah, something like this. Can see? Maybe I'll just use this function instead. 0.5x squared plus 1 and that other guy ln of something. 0.5 is really just half x squared. So half x squared plus 1 and you have a ln x plus 2, huh? So let me change my screen. Okay, so here you got half x squared on top as a red color curve, and then you have ln x plus 2 as the bottom curve, the pink color one. So how do you find the area in between, let's say x equal, I don't know, I don't put a and b. Let's just figure out the point of intersection. Over here, it's 0.398 and 1.774. Okay, I don't want that. I just want something in between. So let's say this is x equals 0.4. Then over there, it will be, I forgot the value. Let me check again. 1.74. So let's just say 1.7 before the intersection. How do you find the area?
Integrate the top minus the bottom.
So integral, tell me the lower limit.
0.4.
Tell me the upper limit.
1.7.
Good. Then top minus bottom should be?
The ln x plus 2.
Oh, non. Top is, oh wait, you're correct. I am sorry, I am wrong. Let me change the color coding. Thank you. Okay, can. You are clearer. The top is the red curve. It is ln x plus 2. The bottom is half x squared plus 1. Yes, I am wrong. So sorry.
Okay.
Yeah, this one minus away half x squared plus 1. Okay, then you can just key in the calculator if you are interested in the answer. I am not interested in the answer. It's okay. You just need the idea, top minus bottom. Okay, can this is 11:50. Oh my goodness. Let me see how many questions I can cover. I was actually planning to go through all the questions in this integration application examples. All of them. And then you got some practice in class. Let me see. How? Still need to talk about integration by region. Okay, let's see. So all right, one of the maybe I'll still go through I'll just go through it. Where should I put it? I should start a new page. Hold on a second. Yeah, this one maybe application. Yes, application examples. So question 1 to 3 you already did it, so that's good. Question 4 this one I'll leave it to you. Okay, 3 no, I just go through that. This one is integrating with respect to y. Do you know how to do that?
Plot the graph first.
You plot the graph first. Okay, so maybe I think I will just go through the examples, then it's easier for you to understand what's going on. Don't need so much theory. For integration is the kind of topic that just requires more of practice. Unlike vectors and functions and sigma notation where it requires a bit more theory. This one you just practice. You have to keep practicing. So this is y equal e power 2x. You'll get definitely pass through 0, 1. Then what we want to find, the exact area bounded by the curve and the y-axis over the interval 0.5 less than equal y less than equal 3. So notice 0.5 less than equal y less than equal 3 is talking about the y, not the x. So what kind of line should we draw? We should draw y equals 0.5 and y equals to 3, not x equals. So y equals, is it horizontal or vertical?
The vertical.
Vertical means up, down. Horizontal means left, right. You know this, huh?
Yeah.
Sorry, horizontal. So you're confirmed horizontal or vertical again?
The y-axis.
No, y equals 0.5 and y equals 3. We're gonna draw 2 more lines.
Horizontal.
Horizontal, much better. Yes. Y equals means a horizontal line because if you see this is y equals 0.5. Y equals to 0.5 or maybe somewhere over here. I'll try to make it look nicer. Yeah, y equals 0.5 is this guy because look at all of its x coordinates and y coordinates. Let's say this guy here was, let's say that this guy here was 2 comma something. What would it be? Must be 0.5. How about this guy here? What would it be? 3 comma 0.5. 4 comma 0.5, 5 comma 0.5, so on and so forth. You realize that it's always, oh wait, you can't see my screen. Sorry. Oh yeah, by the way, whenever I start saying things that you cannot see on the screen, you should shout and tell me.
Okay.
Sorry. Yeah, this is 2 comma 0.5, 3 comma 0.5. So that means that we will have the y coordinate being 0.5. That's why it should always be a horizontal line. Right or not? How do you read off coordinates? Just going along the x-axis and then going to the y-axis. Starting from origin. How many steps to the right or left, and then how many steps up and down. So it's always 0.5 vertical length. Anyways, you should know this from E-math already. I don't want to elaborate too much. Y equals is just a horizontal line, okay? So this is the horizontal line. Where's the other line? Y equals to 3. Must be over here. Y equals to 3. So let's draw that. Then they want the area, they want the area bounded by the curve y equals e power 2x and the y-axis. So where's the y-axis? Over here. Where's the curve? Over here. So what's the region bounded by it? Can you use straight for me on the diagram? Use draw to annotate. What's the area they are looking at? They're asking for. Y-axis there and correct. Yes. Good. Okay. So it's just these 2 regions. Okay, Ken. So how to find the area? Now, one strategy is for you to figure out the x-intercept here, and then, okay, make it dotted line. And then you figure out the area top minus bottom. Then you take top minus bottom. Okay. If you take top here, it's actually just a rectangle, right? So you can find the area of a rectangle. Then if you find bottom, it will be the area of this weird trapezium looking shape, but not exactly a trapezium because it's curvy. And then you just minus. That's how you get this resulting region. But that would be very, very painful and slow. Here, there is a smarter strategy because they already started you off with y. What you want to do instead is to make x the subject over here. Okay. And okay, actually here they didn't ask for exact value, so it's still it's okay to work with the x as the subject. You'll get a ln, which is very bad. But anyways, let's just follow that strategy. Here, this technique is called integration with respect to y. It is in your syllabus. So what you need to know is that whenever you have a function y equals e power 2x and you are bounded by horizontal lines, you can actually integrate from the lower bound to the upper bound, right? But you just need to make sure your x is now the subject instead of y. Then you just need to integrate with respect to y, become a function of y. Is that clear?
Yeah.
So typically, yeah, so let's just write that down. Fy dy, then y equals to something, y equals to something. Okay, so now you just need to make x a subject. In this case, you can see that you can take ln y, right?
Yeah.
Then 2x equal ln y. So x equals to half ln y. All right. Then if you really wanted to, you can bring the half on top as a power. So it's just ln of square root y. Now, since you got ln of square root y, what you can do is you can try to find the area here and here. How? You just go from bottom to the top. So what do you notice as you go? So what you need to remember is that area that's to the left is negative. Area to the right is positive. Similar to how when you are integrating with respect to x. Above x-axis is positive, below is negative. Is that clear?
Yeah.
So in that case, can you see when you are integrating with respect to y, you are now going to be integrating. Let me just copy down the diagram to the side so I can explain while I talk. Don't need to keep scrolling. Yeah, so what you see is that when you are trying to find the area here, it's just integrating from lower limit to the point of intersection with the y-axis, but not the x-axis anymore, which means you're integrating from 0.5 to 1. Okay, then in this case, if you integrate from here to here, what do you notice? This is to the left, so it will be negative, right?
Yeah.
Maybe I should write down the function first in case you're confused. dy. So if it's negative, what do you need to do to make it a positive area? Over here, you need the extra minus sign. Okay?
Okay.
Left, negative, right, positive. So now you continue, you add on the next area, will be integral from where to where? You go from 0 to 1, then where's the next area? You go from 1 to?
The 3.
3, exactly. So lower limit should be 1 or 3? Lower.
The 1.
Then do
3.
3. Yes, same function. Then you can just use a calculator. I know integrating ln of square root y is quite difficult. You need to do integration by parts 1 times. But if this is a question that requests not for exact value, then you can just use a calculator. So let's do it with a calculator. Let me show you. So here, second quit first. You need to know where to find the calculator function. Press math, then scroll down to number 9 for FNINT, function integration. Click here. You know this function, right?
Yeah.
Then just key in 0.5 and go up. You get a 1. Then go to the right. You want ln. So ln here. Bracket is square root y. So shift. Second. Then you just use x. Just know that x and y in this calculator is not, you cannot change it around. You just use the variable x. But then you need oh no, you forgot to put a -1. How do you do it? You can either times -1 or I show you a trick. You press second, you press left, you jump straight to the left.
Oh.
Then press second, press delete button. INS means insert. So your cursor blinks. So the blinking cursor changes. Now you can key in a negative. It will insert in front. Then you can just press enter. Okay, that's the first part. But we are not done yet because actually I can actually scroll up. Then it's highlighted in blue. Just select, and then I just add on another plus math number 9 for integral, and then I key in from 1 to 3. Go up, press 3, go right, press LN, and take the square root of what is this? Square root of x. Second square root here, then press the x button, dx, enter. Okay, then that's your final answer. Yeah. Round off 3SF. Can?
Can.
Okay, that is area. Question 4. For this thing is telling you that you can integrate with respect to y. That's the main lesson of this example. Okay, let's go to the next question. Question 5. Let's take a look at question 5. So here you got question 5. Question 5 is saying find the area of the region bound by the curve y squared equal to 2x minus 2 and the line y equal x minus 5. The tip here is to avoid splitting a region into parts by integrating with respect to y-axis. So let's just quickly draw the graph. Let me copy down the function first. I have yet to change the screen. You cannot see anything. Now you should be able to see. Okay, so these are the two functions. With respect to y, you want to find area. Y-axis, you want to find the area. So let's just draw the graph. Y, oops. Yeah, let's just draw the graph. Clear. Oh, I double click by accident. Okay, go up. You want to draw y squared equal to 2x minus 1. So it's really just plus minus square root. You know this? This is 2x minus 2. So it will it actually intersects at 2, 0. All right? Can? Is that clear? Mic test. Hello?
Yeah.
Are you still there?
Yeah.
Okay, can so now we got a top half of the graph first. So this guy is just 2, 0.
Yeah.
Then you have also the bottom graph. Don't need to draw, you should know straight away. I hope you notice that this is actually just, if you change it to x squared equal to 2y minus 2, right? You sub in the x and y, then you make y the subject, you end up with what is it, x squared plus 2 divided by 2. So x squared plus 2, which is half x squared then plus 1. Do you notice that this is just the, if you just reflect it about this y equal x, you end up with this graph. Half x squared plus 1.
Yeah.
Can, right? I hope you can see. Yeah, then that will be the inverse function. But take note, inverse function, you must pass what test? What line test? Something line test. This one is horizontal, this one is vertical. In order for a function inverse to exist, the original function must pass the
horizontal.
Yes, horizontal line test. Okay, well done. Then therefore you conclude that the function is
one-to-one function.
1-to-1. Okay, good. Your function's okay. Can. Good. Oh, sorry. Let me continue. So that's the first graph. Let me double check first. 2, 0, is it correct? That's not correct. Should be a 4. Let me just double confirm first. When y is equal to 0, it should be 1, 0. Is it? Sub y equal to 0. We get 0 equals 2x minus 2. Bring the 2 over, you get 2x equals positive 2, x equals to 1. So you see, the graph here in the GC is misleading. You see, I thought that it was going to be a 2, but actually it is a. Okay, zoom in a bit. Yeah, here I thought that it was going to be a 2, but actually it's a 1. The graph is incomplete, so you cannot trust the GC.
Oh.
Right? It should actually be a 1, 0, not 2, 0, even though it looks like it's 2. Did I key in wrongly? No, I didn't key in wrongly. So it's really the graph quality not good. Okay, so don't just trust the graph. Take note of that.
Then how do I know it's 1?
Check it manually. You need to know that the square root function is always this curve. Okay, usually this is y equals square root x, the standard curve. Then this is just graphical transformation, right? You go from x into 2x minus 2. Graphical transformation. Then you know that you have to move left, you have to scale by scale parallel to the x-axis by a scale factor of half. Translate 2 units to the right. So that's why translate 2 units to the right, but then you scale half. That's why it goes back to 1. Yeah. Okay, it's just graphical transformation. But of course, you can just estimate. You know that the x-intercept must be x equal to 1, then from there you can draw your graph. Okay, that is y squared equal to 2x minus 2. Then you still have y equal x minus 5. So where's the how does the graph look? Let's just draw it in. So we got x minus 5, x minus 5. Draw the graph. There you go. Something like this. Can? Okay, good. Then in this case, there's an intersection here and here. What do we want? We want the let me read the question again. I forgot the question. Find the area of the region bounded by the curve, the line. Oh, that's all. The curve and the line. Sorry, y-axis not involved. So we are actually just interested in this region here, purple one, and this light blue. Can see? Can. Okay, good. So we want to find the area of these two regions. One strategy is to do top minus bottom. Can you see there's like a top function here and a bottom function here? Yeah. You split it up here. It's really just sorry, maybe I should put this a bit more at a more strategic place, somewhere like here. Then I make my line a bit longer in case you get confused. The top curvy part is actually positive square root 2x minus 2. The bottom one is negative square root 2x minus 2. Okay, then in this case, what you realize is that there's a top graph, there's a bottom graph. So you can actually, if I just color code it somehow, pink color is this top graph, and this orange brown is this bottom graph, and then this light green is this straight line graph. One strategy that you could do to solve this question would be to do the following. Would be to do the following, which is not recommended. Let me show you. Oh, wait a minute. Hold on. Yeah, the non-recommended strategy is the following. Notice the intersection here, draw a vertical line. Then you try to figure out what is this point of intersection. This x equals to something. Then after that, you take top minus bottom. So the first area is really just a equals to integral of the top graph. Can you see what's the top graph? What color?
X minus 2, the purple.
Square root 2x minus 2. No. Purple is the region inside. No. We focus on the graph itself. To the left of the red line, who is on top? Who is below? What color?
It's not the purple, right?
This is a pink color.
Oh, a pink color, yeah.
Yes. Pink color. Oh, it doesn't look like a pink.
Pink color.
Yeah. Okay. So this one is the pink color graph. Oh, okay. You're confused with pink and purple. Okay. I better use a different color. Sorry. Let me try something else. I have so many colors. Let's say I use this. This color, is it okay?
Yes.
Mud green or something. Or then I use light green. Okay, I use something else. I don't know. I'm running out of colors. How can I run out of colors? Maybe I'll use beige. Okay, quite a light color. Sorry, beige. Can see?
Can.
Can also what we are interested in is top minus bottom. So who is top?
The green.
Green. Who is bottom?
The beige.
Wow. Better not use this color. Let me change it to something more simple, like let's say yellow color. Does this look like yellow to you?
Yes.
Okay, I don't use beige. This is so confusing. I'm just going to use green. Dark green. Dark green. Maybe I will just use light green here. I'll just use light green. I don't like that color. Yeah, this one. Sorry for changing the color. Let me change the color code. Okay, so there are three colors here: light green, dark green, and yellow. I think these three colors are recognizable. So tell me, who is on top again? This one?
The green.
Light green or dark green?
Light green.
Light green. Okay, then who is bottom?
The yellow.
The yellow. So in this case, what's the area of this region?
The 2x square root of 2x minus 2, like integrate that one. Then
let's try to find a point of intersection first. Hold on a second. Okay, I need the negative version. So I'll put negative y1. Okay, let me try and find the intersection first. Between the red curve and the black curve. Okay, hold on a second. X equal to 3, comma. This is x equal to 3. This coordinate is actually 3, comma 3, comma negative 2. Okay, sorry, you were saying? So integrate this square root 2x minus 2 and?
Plus.
Dx and plus. Oh, sorry, no dx. Just plus. Can. Also.
Plus integrate. Wait, integrate the 2x minus 2 again. Because it's like above the curve.
Yes, it is above x-axis. This one is above. But here, this guy is negative. If you try to integrate, you can only integrate area from the graph and below.
Yeah, so I put like a negative sign in front, so I get the above the curve.
Yes, correct. Okay, so you put a minus sign here, right? Is it not?
But I thought minus become positive.
Yes, it should be a minus. Sorry. So you're integrating the negative square root 2x minus 2, but you have to put an extra minus sign because it's below the curve, this bottom half, right? So there's a top half, and then there's a bottom half. Good, you didn't get tricked. I was thinking whether you would take top minus bottom. That's wrong. Here, because it goes beyond the x-axis already, you have to draw two separate integrals. This first top area is just integral of square root 2x minus 2, or what's the limit? Can you tell me the lower and upper?
The
1,
1.
1 is the lower.
And then 3 is the upper.
Good. Then this other bottom blue triangle is this guy here. If you try to integrate, it will also be from 1 to 3, but then you will have to put double negative because this first negative is because it's a yellow function. This yellow function, but then you put a minus sign there, it's because below x-axis. Because below.
Can I put like two copies of that one or cannot? Like, can I put
Can.
two?
This simplifies into, yes, just 2 times of x minus 2. It's just algebra,
Okay.
right? Minus minus become plus. So 2 times. Yes.
Okay.
Then you can do that because the limits are the same. If the limits are different, then you cannot do that.
Okay.
Okay. Yes. But we are not done yet. Still need to add on, because we want the entire area, right? Between the curve and the straight line. You also need this region here. Maybe I color in purple. This bottom triangle, as well as this top weird shape. So what do you notice about this weird shape? Can you just take integral of light blue minus array green?
Cannot.
Cannot, because here there's another point of intersection. So we actually need to split it up again into another region. Wow, so troublesome. Do you start to realize it's quite troublesome?
Yes.
Okay, but I'll just quickly give you the answer for this one. The top region and bottom region, because it goes past the x-axis, you have to split it out into 2 separate integrals. So you need to find the area of this top half first, which is the integral of the light green function, square root 2x minus 2 dx. But from x equal to 0 to x equal to, this one need to find out what's the point of intersection here. Sub y equal to 0 to y equal x minus 5, you'll end up with 5, 0, right? 5, 0 here. So this is really just x equal to 5. Here is x equals to 3. Then you have integral from 3 to 5. Okay. And then you have to add on integral of the bottom guy. From 3 to 5 again, but this time it's x minus 5. But take note that because it is below the graph, we want positive area. So what should we do to the plus sign? And the dark purple region is below.
But must put negative sign.
Exactly. Change the plus sign to a minus sign. Wow, 4 integrals already. Still not done. We still got a third region here, the weird shape here. How do we integrate this? Okay, this one is not that bad. You just need to add on the integral from 5 to, we need to figure out what's that point of intersection, or rather just the x coordinate. So let's again look back at our graph. Second, calculate, press number 5. Sorry, it's so close to the edge. The black curve, the blue curve and the red curve, enter, you get 9, 4. So that means I can fill in here 9, 4. Do we focus on the 9 or the 4? X or Y? 9 or 4?
The x.
So here it should be integral from 5 to
9.
9. Very good. So that means you have integral from 5 to 9 of top minus bottom. What is top minus bottom in this case? For the light blue region.
The 2x minus 2.
2x minus, square root 2x minus 2, you mean?
Yeah.
Is the top, then minus
the x minus 5.
What's missing?
Bracket.
A pair of brackets. Then you can type this entire thing in the GC and you will get the answer. Long-winded or not?
Yes.
Yes, so now that's why this question has a very strong suggestion. Do not try this. If not, you will run out of time during exam. Instead, here is the recommended strategy. Okay, maybe I just color code this guy first. Can
I use like triangle?
Triangles can no, these are not triangles. It's a curve.
Like the
this one here,
the
this one
blue region.
The blue region, here's a curve.
Like
it's
not
a triangle.
Like I integrate everything that I minus the triangle, can?
Can also. That's the same thing. Can. You can find the area of this triangle, then you just so what you're saying is you are trying to find the area from here to here, this shape, and then you minus away the area of a triangle here. Yes?
Yeah.
Can also.
Okay.
This area will be half times the length here is 4, length here is 4. 9 minus 5 is 4. That's how I get the 4 at the bottom. 9 minus 5 is 4. And this height here is 4. So half times 4 times 4. Yes. That's really just the integral of x minus 5 from 3 to 5. Can also. But it's very long-winded. This is not the point I'm trying to drive at. Okay, I just draw a funny little triangle, not really a triangle, but more like a curve shape like this, to represent each of these regions. So it's very slow. The recommended strategy is actually just to interpret like this. Look from this direction. Imagine the gravity is going downwards in this direction. Okay. And then you integrate with respect to not x, but rather
Y.
y. So that means that you have to integrate from the bottom to the top. Okay. So what do you notice? Straight away, if you go from bottom to top, actually this point, let's just label the coordinates again. It was 3, -2. So here the y is -2. How about here is 1, 0, so the y coordinate is 0. How about this point here? It was a 9, 4. So that's why I'll label 9, 4. This y coordinate is 4. Then how to integrate? It's very simple. Area is just purple plus blue. The purple region plus the blue region, dx, plus the blue region. Okay. How do you get the purple region? Very simple. You see, you go from bottom -2 to 0. So that's why your limit goes from -2 to 0. Then you look at this graph. Oh, it's entirely above the y-axis, never pass through the x-axis. So you can just do the top minus bottom trick. What's my top graph? It's just y equal x minus 5. So do I put x minus 5? Sorry, I forgot. It should be dy. Wrong. You cannot. You have to change to the y world. So y equal x minus 5, you have to convert it to make x the subject. So x equal to y plus 5. Okay, so here it should be y plus 5. Can? The light green. Can see or not?
Can.
Guy here.
Yeah.
Then not enough, you still need to subtract away the bottom. So who is the bottom? It's this brown color curve, right?
Yeah.
What is this function? Y equal negative square root of 2x minus 2. So can you just put in directly? When you are with respect to y, everything must be in terms
y
of
version.
y. So what do you need to do? Make x the subject, right? Yes?
Yes.
Okay. Can. So let's just do that. Square both sides of the equation. We get y bracket square equals to bracket -2x minus 2 square root square. So you get y square equals to negative square become positive. Then you get square root square also become positive. Sorry, square root and square will cancel each other off. Then you're just left with 2x minus 2. Bring the 2 over, you get y square plus 2 equal to 2x. Then divide by 2, you get x equal y square plus 2 over 2. So now you got y square plus 2 over 2, then you can sub in y square plus 2 over 2. Can? Upper region? Good. How to find the blue region? Try.
The
Lower and upper limit. From here to here already. Next one will be what to what?
The 0 to 4.
So 0 to 4. Okay, then what's inside?
The y plus 5.
Y plus 5. Good. That is your top graph.
Minus the
Open bracket.
Minus the y square plus 2 over 2.
Correct. Well done. Here, both functions. This is just this is x. This entire curve is x equal y square plus 2 over 2. So it's just one curve. Yeah. So y square plus 2 over 2. So do you notice this is much simpler? Faster.
Yeah.
But the thing is, you need to know how to do it. You need to make x the subject, and you need to go to the y world. Okay. And the reason this is simple is because it doesn't go past the y-axis. It stays on top. It stays within one region. Then you can just do top minus bottom. Okay, compared to the other guy, you see, you have to split up the purple as top and bottom. But you cannot do top minus bottom. You need to integrate until the x-axis, find the light purple region, and then you integrate this dark green, the y equals to x minus 5 with respect to x-axis, and then you add them together. And also because it's below the x-axis, you need to put in an extra minus sign. So there are many things going on. I'll leave it to you to check on your own that these two answers are the same. You can use a GC. You can use a GC. All right.
Okay.
Let me just make it look a bit nicer. Drag this down. So the main point here is integrate with respect to y. Please learn how to do it to save time. That's the moral of the story. Can understand, huh?
Okay.
All right. Yeah. Check that they will be the same on your own. Let me know if there's any problem.
Okay.
Okay, that is this question. Wow, I have time. It's already, what time is it already? It is 12:30 and I'm not done. Can I just skip a few questions and then I'll assign those as homework? Let's go to question 7. Let's take a look. Parametric integration. This is quite important. So for parametric integration, right, what you realize is that they will give you two functions in terms of x and y. Okay. They will give you the function for x and a function for y in terms of what we call a parameter theta. Okay, some in between variable. So you can actually combine them together to get an explicit function y equal f of x. But that's not the point of this question. Please don't try and do that. That's not the point of the question. And they will give you the parameter boundary from 0 to pi over 2. So what you want to do is to sketch the curve indicating that clearly the axial intercepts. You can use a GC for this. So let's do that. If I'm not wrong, is it? Oh wait, did I download it? Oh, hold on a second. Right. No, don't need to download. Oh my goodness. Go to mode here, right? You have your GC with you, right?
Yeah. Okay.
Let's do together. You see parametric? Select it. Then you go back to quit and then y equals. You see x and y. Okay, here the calculator only uses the parameter t.
Yeah.
So just in this case, our question is using theta. So just treat that as t, t for theta. Okay, so 3 cos theta or 3 cos t would be 3 cos variable, close bracket. Then y will be 2 sine theta, close bracket, and draw the graph. Okay, they give you a ellipse. It's actually an ellipse. So this is the parametric form of an ellipse. So let's just draw it first using the GC. You can make you can use like a square. You can square both sides of the equation and then you add them together, and then you try to somehow use the sine square plus cos square equal to 1 formula to help you convert this into an explicit function, y directly equal to x no more theta. But that's not the point of the question. Just use GC can. Okay, so I can see that this should be a 3 here, -3 there, and then there will be a 2 and a -2, roughly. Not roughly, exactly. But my drawing is roughly. Okay, Ken?
Okay.
But they also tell you something, 0 less than equal theta less than equal to pi over 2. Here, what they did is if you press window, they have a T min and T max, min for minimum, max for maximum. T is your theta. Here it goes to 6.28. Do you know what 6.28 3185? Pi is 3.14. So this is actually 2 pi, right?
Yeah.
Your value went from 0 to 2 pi. We don't want that, so we restrict it back to pi over 2. Where is my pi first? Over here, divide by 2. Okay, 1.57. Then we just draw a graph. Oh, you get the updated graph. It's actually just 1/4. It's actually just this quarter. Not exactly a quarter, but you get the idea. Ken? Good. So yeah, just draw this graph. Here it will be a 0,2. Here is a 3,0. Then what do they want? They want us to, let's read the question first. Sketch the curve indicating clearly the axial intercepts. This guy here, 0 less than equal theta less than equal pi over 2 is very important. It's the domain of the function, or domain of the parameter, which is the domain of the function. So you have to make sure you follow the rule. Don't just draw an ellipse, follow the rule. Stop at pi over 2, which means that your graph will only go from It will go from the bottom here all the way until the top, and then it stops. Maybe also to make it more precise to show your understanding, because I included an equal sign here and there, you should also have a circle and solid circle. Circle, then solid circle to indicate you include those points. Let me ask you, if I have a strictly less than, don't have equal, what do I do to this? Which point should I, one of those points must become an empty circle, right? Which point? Which point should become empty circle?
The 3,0.
Okay, maybe I should do this as a totally separate question because it's not the question 7. Let me copy and okay, this is not question 7. This is extra. This is extra. Sorry, which one? Left or right? The 0, 2 or 3, 0?
The 3,0.
The 3, 0. Then you are wrong.
Oh.
The point that is affected occurs when theta equals pi over 2. So let's figure out what's the x when theta equals pi over 2. It's 3 cos pi over 2. What's that? Zero, right? 3 times 0. So it's 0.
Oh.
And how about y? Y is, by now you know, it must be 0, 2. Y should be 2. Let's check. 2 sine of pi over 2 is equals to 2 times sine of pi over 2. That's just a 1. So 2 times 1, which is 2. Okay, so 0, 2. It's this point. How, actually, there's a faster way you can figure this out. There's a faster way to figure this out. You see, the theta value increases from 0 to pi over 2, agree?
Yeah.
Then you look at the graph. I draw the graph again. Let's say I go back to mode. I change this to like a 5. I draw graph too slow. I press the on button to terminate. Then I change it back to a 3. Here, I'm going to make my calculator speed go to 25% just to be more, show you what's going on. Look carefully at the animation, okay? Or use your GC and see what happens. Do you see? It slowly grows from the right to the left.
Yeah.
It went in this direction. That's because this here is theta equals to 0. Then here, this other point here would be theta equals 0.1. This other point here would be theta equals 0.2, and so on and so forth until eventually it reaches theta equals to pi over 2. Okay, it's just plotting points. Plot, all the way as theta increases from 0 to pi over 2. So that's why when I tell you 0 is less than pi over 2, you should pay attention to the direction that the graph is growing in. Pi over 2 is the last point. So it should be this guy that should become an empty circle. Clear?
Yeah.
Do you know how to sketch a parametric curve now using GC?
Yeah.
And just take note. But this is an extra question. Oh, sorry. This is an extra question where I purposely dropped the equal sign. The actual question did not drop the equal sign. It's a lot simpler. Let me modify this. This is no longer extra question. I go back to question 7. Question 7 has a equal. So you just need to draw in the solid circle. Don't even need to care about the direction anymore. Very simple question. That is your part 1. Sketch the quadratic curve, not quadratic curve. Sketch the parametric curve. Part 1 done. Let's look at part 2 now. Part 2 tells you find the exact area bounded by the curve with the axis. So in other words, find this region here. How? Let me show you the procedure. Actually, ultimate summary already mentioned it for at the bottom. If I didn't, did I not mention it? Oh, it's not mentioned. Oh my goodness. Sorry. Okay, it is basically extremely similar to this guy. Oh, integration by substitution. Let me show you how to do it. Sorry, I forgot. I didn't mention this. Let us go through it now. So the goal here is for us to integrate this y with respect to x. Okay? And then we want to go from theta equals to, you use the parameter theta equals to 0 to theta equals pi over 2. Okay, but of course it must be actually here it should be in terms of x. Sorry, x equals something, but we don't use this format. We have to convert it into the theta world. So it's some function of theta. Then dx also has to become d theta, and you need something in front. Some happy face that is in terms of theta. And then your limits must change it to theta equals 0, theta equals pi over 2. So this, you can just throw it away. This is the formula that you should be focusing on. Okay?
Yeah.
Then it's like integration by substitution. Y sub in with something in terms of theta. Dx substitute with something. So how do you find dx? That means you need to do what to
Integrate,
this?
differentiate.
Differentiate, exactly. Then the limits will always be theta equal pi over 0 to pi over 2, if I am not mistaken. Okay, let me just change my screen first. Okay, hold on a second. Yeah. Okay. Can start. Let's go. So in this case, when we are trying to integrate, what we need, you need to replace the y, right, with something in terms of theta. But do we have something for that? Right over here, right? Right over here.
Yeah.
So that means our f theta is actually 2 sine theta. So we can just straight away a equals integral 2 sine theta. Then how about this d theta with a happy face theta in front? How do you get this from dx? It means that you need to differentiate with respect to theta. So what do you get? 3 times negative sine theta, which is minus 3 sine theta. Make dx a subject. Dx
So the
equal minus.
limits I also sub into the x equals 3 cosine theta.
Sorry, say again.
The limits I find from subbing in the x equals to 3 cosine theta.
Yes, but there is no. Okay, sorry. I forgot to mention that since we already draw the graph and the x-intercepts, we know we are trying to find integral of area from 0 to 3. So I should just put down 0 to 3. But you should know straight away that it will become 0 to pi over 2, the limit, the end limits of the domain.
Oh, so I don't need to sub in at all.
It's a shortcut, but that technically, yes, you should. Technically, you should.
Okay.
Okay, I'll do that because just to show that it's the same as substitution, but it's guaranteed it should be the same. X equal to 3, x equal to 0, draw an arrow. We try to convert. So this means 3 equals to 3 cos theta. Divide by 3, you get 1 equal to cos theta. Cosine theta graph, I'll just draw it here. Y equal to 1. The intersection is here, so that means that theta equals to 0. Oh, 0. Let me see. Did I do something wrongly? Oh, right. Sorry. Hey, actually, it's safer to substitute. I forgot the direction. This is theta equals 0. That's theta equals to pi over 2, right?
Yeah.
So it should actually be from left to right. Theta equal pi over 2 on the bottom and theta equals 0 on the top. Okay, I'm so sorry. Oh no, you're correct. We should substitute. Then what will we get? We'll get x equal to 0. Then it's 0 equals to 3 cos theta. Divide by 3, we get cosine theta equals to 0. Then draw the graph. Y equals 0 here. So it should be a pi over 2. Here, pi over 2. Can? Okay, can. Yeah, sorry about that. The lower and upper limit, you have to actually care about the order. Cannot just follow the theta here, and then put 0 and pi over 2. Wrong. It's pi over 2 on top. Pi over 2 below and 0 on top. Then you have the integral of 2 sine theta, but the dx you're gonna replace with this guy over here, minus 3 sine theta d theta. Okay. And then after that, you're gonna, and that's it. That's all you need. Okay.
Okay.
Then you just proceed to integrate this trigonometrical integral. Let's do that together. So we get pi over 2 at the bottom and 0 on top. Actually, you can also swap it around. So 0 at the bottom and pi over 2 on top. But then you need to factor out a minus. Do you know this? Swapping, you can introduce a minus.
Oh, I didn't know that.
Yeah, because like let's say a simple example from 1 to 2. This is 1, this is 2. When you go from 1 to 2, you will get the positive answer. Let me show you. You will get x squared over 2. Then you need to sub in 2, 1. Remember, you have to subtract, right? So it becomes 2 squared over 2 minus 1 squared over 2. But now if you swap the order around 1, 2, what happens? Sorry, 2, 1. You just get back the same answer, but then you have to swap around the 2 and 1. Then you end up with 1 squared over 2 minus 2 squared over 2. So they are just times -1 from each other. Right? Yes. So that means that integral 1 to 2 of x dx is equal to -1 times of 2, 1 integral of x from 2 to 1. Okay?
Yeah. But why do I need to swap in this question?
Oh, there's no need. Just to make it look nicer, honestly. No need. There's no need to.
Okay.
The minus here, I just want to cancel off the minus there. Okay. So 2 times -3, you get a -6. Then sine theta, d theta. That's really just sine square theta. I'll skip a step. Is that okay? I skipped the step.
Okay.
Sine times sine is sine square. Then negative and negative cancel off, you'll become a positive. So that it looks nicer. There's no need to do the swapping. So yeah, then you get 6 times the integral from 0 to pi over 2 of sine square. So that's when you need to recall the formula that's not provided in formula list. Double angle identity. Let me just shrink this down. Put it outside. Okay, so here we know that cosine 2 theta is equals to what? Cos square theta minus sine square theta. There's also 1 minus 2 sine square theta. So now I can make sine equals to cos 2 theta on the left. So now I can make sine square theta the subject. So 2 sine square theta equals to 1 minus cosine 2 theta. Yes?
Yeah.
Then just divide by 2. So sine square theta equals to 1 minus cosine 2 theta divided by 2. So you get 6 times the integral of 1 minus cosine 2 theta divided by 2 d theta integral 0 pi over 2. Over 2 can factor out, so you get a 3. Okay, I'll do it step by step. 6 over 2. Then integrate 1 minus cosine 2 theta d theta from 0 to pi over 2. Equals to 6 over 2 is 3. Simplify straight away. Then you get the integral. I will also integrate straight away. 1 becomes a theta. Cosine becomes a sine 2 theta. But what else? What's missing?
The over 2.
Divide by 2. Very good. Then you sub in, put in the limits 0 to pi over 2. So now you can sub in 3 times of something minus something. Just do it step by step. This one, maybe I'll skip a few steps. Theta sub in with pi over 2, you get a pi over 2. Then you minus here sine 2 theta over 2, I'll put down the over 2, but then here I'll evaluate straight away. Sine 2 theta, sub in the theta with pi over 2. 2 times pi over 2. Is it okay if I skip a step?
Okay.
I just show you straight away this guy. 2 and 2 cancel off, it becomes a sine pi. Sine pi is really just here, so it's 0. So 0. Of course, you can even skip a step even further and just write down minus 0. Then minus away, sub in a 0. You get a 0. Oh, what happened? You get a 0. Then you sub in the 0 to the other guy, get sine of 2 times 0, which is sine of 0, which is
1.
sine of 0. X equal to 0. Sign is
Oh,
0. Yes. Sorry, my graph overshoot the y-axis. Yeah, so there should be a 0 now over 2, which is minus.
1.
No, I'm substituting theta with 0 now.
Oh, 0.
Minus 0 over 2, which is still 0. Okay?
Okay.
Can? So
Okay.
why did I want to swap it? It's also because here you notice if I didn't swap it around, pi over 2 and 0, I never swap around. What happens is that I'll have to put down the 0 in the front. So I'll end up with 0 minus 0, then minus away pi over 2 minus 0. What's the problem with this? You need an extra minus in front. Then you need to distribute into the bracket, which is confusing. Compared to this version, minus 0, 0. I don't even need to worry about negative numbers anymore. You see that?
Yeah.
Okay, but this one maybe a bit that one, this is only after this is like optimization, making it faster already. Your first priority should be to figure out how do you get from this guy into this guy. You need to figure out this procedure. It's just doing substitution. Okay, it's integration by substitution. Can?
Can.
Okay. Yeah, then just simplify 3 times pi over 2, then you get pi. Can?
Can.
Okay, good. So that is question 7. Do I have time for one more? Oh, question 8. Never mind. I'll talk about it next time. Question 9 also.
Okay.
Wow, volume of revolution. Can I just talk about that one question?
Sure.
Let's go through question 10. Let's take a look at question 10. Quick one. Okay, so you gotta read. So first thing you need to know, volume of revolution. I already explained to you last week. If I can find it first, the intuition. Yeah, remember this one?
Yeah.
So the intuition, if you don't understand it, right, you need to remember this formula. Pi times the integral a to b fx squared minus gx squared dx. Just treat the pi as if it's pi. Treat the fx squared as if it's r squared. Treat this gx squared as if it's little r squared. Then minus is minus. Then the integral is just adding a bunch of these rings, and then dx is like a height. So the intuition for this will be whenever you have trying to find the volume that's the volume of revolution of the region that's surrounded by 5x and 2x. So it means that you have this, you have this rectangular piece, and then you rotate one circle around so that you can get one cylinder here, and you repeat it for many, many times. Repeat many, many rings. And then eventually what shape will you get? You'll get a cone, but then in the middle, you have a hole that's cut out, also a cone. Or could be other shapes. So the intuition behind this is you need to find the big volume of one donut, big volume of one cylinder, then you minus away the volume of the small cylinder inside so that you can get the donut. Donut equals to volume of the big minus volume of the small. Is that clear?
Yeah.
The hollow region, the hollow region. Then the big has a big radius, big R. The small has a small radius, small r. So I hope you can see there's the big R, and then you have little r. So volume of this big one will be pi times r square times h. In this case, h is usually what we call the delta x. Okay, delta x means change in x. Okay, it's referring to this length here, delta x. We try to make sure that their length is the same. Okay, then this guy also delta x. How about the v of the hollow region, the v small? Or v hollow. Oh, this volume b. The height here is delta x, or maybe if it's confusing, I don't use delta x for now, I just use h. What's the volume of this small region? Small cylinder. Base area times height. What's the base area?
It's pi
Circle.
pi r squared
10 times.
h.
Good. So now if you want the net volume, big minus away the small. So that's why we end up with, maybe I'll just start a new page for this one. So that's why we will end up with the resulting net volume to be V net volume to be V big minus V small. So what do you get? You'll just get pi capital R square times H minus pi little r square times H. Factor out the pi, factor out the H. You are left with what in the middle? R square minus R square. Is that okay?
Yeah.
Can Then how do you get R? It's capital R and small r. It's really just fx and gx. Remember, the radius is like the height of this vertical line, which is really just the y coordinate. So if you have x, then you have, if this is function y equal f of x, and then you want to find like a, can you visualize the cylinder, the cone, sorry. If you want to find this vertical height, which is the radius, it's just the y coordinate of this point over here, right? Can you see?
Can.
This vertical height length, the length is f of x. So for example, if this is y equals to 2x, here is x equal to 3, this will be 6. So the fx equal to 6. The height of this vertical line is really just the radius of a cylinder you're trying to create. Okay, so that's why you got fx and gx, but then you want to, that's only just one such cylinder, minor cylinder. You want many of these cylinders. So that's why when you do integration, you're adding up a bunch of these cylinders together. That's why volume of revolution equals to sum of all the V net. Okay, this is a very bad notation, but eventually you'll just get pi and h, but we change the h to dx. Then r square minus r square is fx square minus gx square with brackets. And then you want to add everything together, sum everything together. So you change this into an integral. Okay, and then let's say you go from here to here, a to b. So you go from a to b. Can? Memorize this formula. Pi times big R square minus small r square. Then you have dx, and then you add everything together. Okay, can remember this? Can? Okay, can, good. Let me change a few things. Okay, and then here, and then I finally go back. So remember the formula again, V is equal to pi times integral from a to b, fx square minus gx square. So it's similar to the top minus bottom formula, but with extra square. Huh? It's just like a top, similar to the top and bottom formula. Compare and contrast the difference. No square. There's an extra pi. Okay? Pi r square, because we want to find volume of cylinder, must have the base area pi r square. That's why there's a pi here. Okay, that's the intuition behind it, finding volume of cylinders. So let's read the question now. Question 10. A region bounded by the curve y equals to x squared plus 1. So let's just quickly draw a quick sketch of that diagram. So it's something like this. The x-axis and the y-axis and the line x equal to 2. X equal to 2 is where? Here. Is rotated completely about the x-axis. So what region are they referring to that they are trying to rotate?
Like here.
Where? Are you drawing something?
Yeah.
Oh, sorry. Did I not show the screen? Oh my goodness. Wait. I did share the screen. Oh, sorry. Yes, correct. That region, the red color one. So it is just the region bounded by the curve, the x-axis. The curve is here. The x-axis is here. The line x equal to 2. Yeah, then they also, I think I forgot to mention x equal to 0. Y-axis. Y-axis is x equal to 0. Okay, they were implicitly saying x equal to 0. You know, right? Y-axis is x equal to 0. Yes?
Yeah.
Yes, Good. That's from O levels. Then you got this region here. Then it's rotated completely about the x-axis. So it means you're rotating around here. Can you visualize? You create a sort of volcano shape.
Yeah.
3D, must think 3D. Okay, so how? What is the top graph and what's your fx? What's your gx? fx is like your top. Gx is like your bottom.
The fx is x squared plus 1.
Good. Yes. How about bottom?
X. Y
x-axis.
equals to 0.
Yes, correct. Y equals to 0 is the x-axis. So this is actually just x equals 0. So that means you're minusing 0 square. You can just ignore it. Okay? But the general formula should be top and identify the top function and bottom function. Then you know what's your A and B?
Yes.
What is A?
0 and 2.
Okay. Then now you just use the formula. So V equals to pi times integral from
the 0 and 2.
0 to 2. You read like this, 0 to 2.
Oh, 0
bottom
to
to top.
Okay. Then the x square plus 1 square.
Bracket square, good. Minus 0 square. Of course, if you are fast enough, you can see that it's minus 0. You can just ignore it. Dx. Done. That's it. Easy or not?
Okay.
Easy. Very easy. Just use formula only. It's like big R square minus little r square. Integral dx pi. Good. Okay, then you can just type in a calculator this one. Of course, this is actually quite simple to integrate. So let's just quickly do it. X square becomes x power 4 plus 2 x square plus 1 a plus b bracket square. Then you get pi times integrate this. So x power 5 over 5 plus 2x power 3 over 3 plus x 0, 2. Sub in 0, sub in 2. So you get pi times 2 power 5 over 5 plus 2 times 2 cubed over 3 plus 2 minus away 0 plus 0 plus 0. So you get pi times, this is gone. So you just calculate this in a calculator. 2 power 5 over 5 plus 2 times 2 power 3 over 3 plus 2. Learn to do it fast, this one. Try. But don't make careless mistake. So that's your answer already. Pi times 206 over 15. Can, okay. Still got another question. So the trick here, you will need to remember the general form, which is just top then minus bottom. In the practice question, I want to later I'll mention it. You got y equal 2 over x and the line y equal to 2x. So you need to know who is your top and who is your bottom graph. Then all you need to do is to use the formula, okay? Fx squared minus gx squared. Oh, but here, there's also region rotated about the y-axis. It's also in your syllabus. So let's just do a quick one. Let's say I give a simpler example. About y-axis, it's very simple. You just need to make y the subject and just use the formula. So it's just v equal to pi from c to d. I just change the formula. Then you take fy square minus gy square. Then dy. That's all. I'm just replacing the x with y. Let me bring down the formula from before so you can compare and contrast. Okay. This is the formula for with respect to y. It's just c to d. So let's say we do a quick example. I want the region bounded by y equals to x. And y equals to, I don't know, ln x. No, that's not correct. Maybe something like this. Y equals to ln x plus 1. Let me just check first whether this works or not. Hold on a second. Okay, nope, it doesn't work. Let me just change this into a 2 first. Yeah, okay, now it works. So what's the region bounded? So my graph looks very awful. So I'm going to redraw it. There's a curve like this, there's a line like this. I'll make it more dramatic. So I'll make my vertical longer and my horizontal shorter. So I can draw something like this. Maybe like this. Then you just draw something like this. Okay, not much of an improvement, but I hope you can see what I'm trying to get at the region here. Can see or not?
Can.
Okay, good. So that is those are my two functions. I want to, this is, and the region bounded between them, the red color region. I want you to find the area, the volume of revolution about the y-axis. How would you do that? So what you need to do is to imagine your gravity is now this way. Okay, previously, you can think of it as like the gravity is pulling you downwards like this. So you can see as you imagine you have a guy who's carrying a parachute, okay? And if you slowly dropping down, what's the first function he will land on? X squared plus 1.
Yeah.
Right? That's the top function, the first one you land on. And then he continues dropping down beyond that. He lands on the floor, which is y equals 0. So that's your bottom function. But now, when you're doing volume of revolution, you think your gravity is dropping this way. So your tiny man is over here. I don't know how to draw. Okay, parachute. Then he is dropping down this way. What's the top function? First function he will land on.
The ln x plus 2.
Oh, look carefully. Maybe it would help if you draw horizontal lines like this. Let me just try and see if I can somehow make this diagram a bit more dramatic so you can see more clearly what I'm trying to get at. So this guy, parachute man, is x-axis here, intersection here. You want this region. So you're gonna rotate about y-axis. Maybe it would be helpful if I just indicate these point of intersection and I draw vertical lines like this. Does it help? Who is the top function? Who will you land on first?
Y equals to x.
Y equal x is on top, right? So that means this guy is on top and that guy is below. But now, because you are integrating with respect to the y-axis, similar to just now when we are finding area under the curve, you should make what as a subject? You should make x as the subject. So here you already have x equal to y, but here, how to make x a subject?
Must change to exponential.
Yes. Slowly, plus 2 bring over. Minus 2.
Minus 2.
Because ln x. Maybe I swap it around. Ln x equal y minus 2. Then x equals?
E to the power of y minus 2.
Okay, very good. So now you have the two functions already. So can you tell me again, x equal to y and x equal e power y minus 2. Who is top, who is bottom?
The y equals to x. The x equals to y.
Good. So therefore, your volume of revolution, use the formula now. What will it be? Pi times the integral from what to what? Oh, I should label the coordinates. Let me give you the coordinates. This is 0. You just use an inaccurate answer. 0.159 to 0.159. And that guy over there is 3.146, 3.146. What a coincidence, it's the same. It's because I'm using y equal x. Okay, you know what? Pause. Let's change the function. Let's change the function. I'm gonna change this to y equal x plus 1. Then this is x plus 3. Then in that case, I'll be a minus 3. it will be a minus 3. Then here it will be x plus 2. So if you make x the subject, it's actually, oh, no, this is x plus 1. So that means x equals to y minus 1. Okay, sorry for the abrupt change. So it's y minus 1 and e power y minus 3. And then the coordinates of the point of intersection is a increase by 1. So in that case, it would be 1.159 and then 4.146. Okay, carry on. What should be my C and D?
The 0.159.
No.
But I thought it's in terms of x.
That's when we are in dx. Now we change to dy. So maybe I should label a y equals here to remind you. Sorry, I never explained properly. Now you understand? You use the x, But now, when we move on to integrating with respect to y, dy, right? We have to use horizontal line, which means it's y equals something. So what is it?
The 1.159 to 4.146.
Very good. Yes. Okay. So sometimes the question will just ask you to find the integral. Then you don't need to, they never ask for exact. You can just use the decimal approximation and use GC to calculate. Okay, so what's my Fy square? What's my Gy square? I write down for you first the square.
The y minus 1 square.
Y minus 1 square.
Minus the e to the power of y minus 3 square.
Very good. Yes, that's all. Then just use GC. Of course, if you want, you can do it manually. I'm not interested in the answer. I'm interested in your setup. This is more important. The first step. Okay? The rest is integration techniques. We already covered that. Now we are going to application. So this is the application. You need to know how to set up the correct equation. Okay?
Yeah.
Okay, just to recap, for integration, for finding volume of revolution about y-axis, you think of parachute from the right side landing in this direction. The gravity is falling in this direction. So the top graph, bottom graph, from the parachute, you can tell who is the top, who is the bottom. Then I draw these fancy horizontal lines just to indicate the direction. Can you see? Just like the direction of gravity, I draw these horizontal lines. Then you can tell very clearly who is on top and bottom, right? Green is on top, then blue is on the bottom. Like if you just rotate your screen around. Yeah, okay, can. Then recap again, this one is volume of revolution about the x-axis, dx. So it should be now x equals and x equals. We focus on x equal the two vertical lines that are surrounding this region. And then you just identify who's the top and bottom. Here, the parachute guy should be here. Then he lands down. The top is x squared plus 1, the bottom is 0. So that's how you get a fx is x squared, gx is 0. Then you minus, you bracket square, then you minus. Okay, and you integrate from x equal to 0 to 2 over here. Okay, then the next previous example about parametric integration, you just need to know that it's integral of y dx from x equals 0 to 3. Sketching the graph, you can refer to the video again about how I demonstrated using the GC to sketch this. Then you just need to sub in the theta by doing the procedure for substitution. Just need to take note of 3 things. Number 1, your limits must be changed. Your limits x equal to 3, x equal to 0 must find the corresponding theta value. Number 2, you need to sub in your y with something in terms of theta. It is provided already over here. Then the number 3 thing is you need to substitute your dx with d theta. Okay, maybe I circle the 3 things. This guy must change to this guy. Y need to change to f theta. Then dx must change to something d theta. How do you get those three components? The purple part, you must differentiate the x. The light blue part, you just need to substitute the y. Then the limits, you just need to calculate it on your own over here. Oh, okay. Hopefully you will remember these three parts. Always check that you got these three parts. The limits, the integrand, and then the dx change to something in terms of d theta. And then you just carry on. Trick here is to swap the limit around, then you introduce a negative. So you make your life slightly easier. Negative, negative cancel off. Less careless mistakes. Yeah, then here also a thing to take note is if the limit here doesn't include the pi over 2, then sometimes you need an empty circle. Just be careful of that. Then here it's one nasty example where you want to find the area bounded by these two regions. If you try to integrate with respect to x, you will have a very hard time because you need to split it up into many components with respect to x. Oh, sorry, I shouldn't say with respect to y-axis. I should say make use of the y-axis instead of the x-axis. This is difficult, whereas if you make use of the y-axis, you imagine the parachute man is dropping down this way. Who's the top function now if you drop down? I think you can see straight away.
-5.
Ah, very good. But also take note that because this is integrating with respect to y, you don't use x minus 5 directly. Instead, what do you need to do? Make what the subject?
The x.
Make x a subject. Then you can use. Likewise for the 2 square root 2x minus 2, make x a subject. Okay. Then you identify your top and bottom with the parachute man. I hope that's, I don't know if that's helpful or not. Just top and bottom from this direction. Then after that, we also had integration. This one is also another example of integration with respect to y, where it will be more useful. Yeah, then the thing to take note is that when it's to the left of y-axis, it's negative. So that's why you need to introduce an extra minus sign to make sure it turns into a positive value. Area must be positive. Area positive. Then the other guy, you just integrate as per normal. Just remember you go from bottom to the top. 0, 1, 3. Okay, that's all for integration. I mean, I haven't covered some other topics still, but I think this is enough for you to do more practice questions. I'll assign you your homework later.
Okay.
That's all. Bye-bye.
Thank you. Bye-bye.